Welcome back to Rocket Kyan, my fellow space tubers. And okay, so today we are having uh I must say this launch will be a launch which will be remembered in the history books, because this is the launch which is being done by Blushift Aerospace. And I know you haven't heard about Blushift Aerospace and everything, so don't worry, you are at the right place. And I'll try to say whatever I can, whatever I know about this company and whatever they are doing. So just drop me some questions in the chat and I'll try to answer them. So why did I say the it will be written in the history books? Because this rocket, as you know already from the thumbnail, is will be using a bio-derived fuel, which means the last time someone managed to make a new rocket fuel, it was around a decade ago, if I'm not wrong. And this is the smallest company, and this is a startup right now, like every other startup. SpaceX also was a startup initially, Rocket Lab also, and then now this, the Blushift Aerospace is working on in that direction. And hi everyone, hi Eric, hi Bill Dodson, hi Anamika, hi Iron the Space Explorer, and hi Ant-Man. So without any further ado, let's just have a look as in what this company is. Okay, so this company, you can see, right, designing and manufacturing a bio-derived fuel-based rocket, which means right now they haven't disclosed as in what fuel they are using and everything, which means that is what they say is proprietary right now. But in near future, when their technology is proved, like for today, this you can say is more likely a technological demonstration mission rather than a normal one. But there are payloads on it, so do look out for that also. So yeah, it is basically manufacturing bio-derived fuel based rocket, which means the fuels will be cheap, will be safer, and will be accessible from local farms. That's what this company aims for, and that's what it is right now. It's actually having in its research and development on. So yeah, so what makes Blushift different? The thing, okay, I'll talk about this later. And the funding, you can see right now they don't have any they are just a startup, and they don't have any official investor or something like that. So whatever they have done since 2014, they are working, and they have invested this over its own resources. So if you want to guys support this startup, you can just become a Patreon or buy a Blushift merch, and you will be able to help them. Okay, so our rocket, so yeah, this is their rocket lineup, what they are aiming for. Okay, and right now, which you will be seeing, the launch of the rocket will be this, the Stardust Gen 1. And then they have okay, they have four rockets: Stardust Gen 1, Stardust Gen 2, Starless Rogue, and their Red Dwarf. Okay, so what's the difference between all these? The rocket which you will be right now seeing today will be a sounding rocket, which means that it will go to a certain flight and height, and then come down. Same is with this Gen 2, although the difference between these two is that this will have a longer flight time, but still it's just a sounding rocket. And it won't go to space. These two rockets won't go to space. They are more like sounding rocket, having just providing some microgravity environment, simulated, or you can say near microgravity environment to the payloads. And that's what they will be doing with these two rockets. And then finally, with the Starless Rogue rocket, they will be going into a suborbital trajectory towards the space. So you can see here, it will be, the accelerations will be less than 5g, and providing some of the longest 0g time of around 6 minutes. So that is really very cool. And it reaches hypersonic testing by reaching velocities of Mach 6 to 7. So it's a two-stage rocket which you are right now seeing. This is a two-stage rocket, and yeah, this will be a suborbital rocket. Then comes the red dwarf. Now with this rocket they aim for orbital class insertion of the satellites. This will be mostly they are aiming for the polar satellites, means the sun synchronous satellites, the sun synchronous orbits which they are having, and which mostly CubeSats prefer to have sun synchronous orbit, because then they can track at the same place on the earth whenever they come at um, that point. Also they are able to get sun, which means the solar panels can work all the time. So sun synchronous orbit is basically preferred orbit for most of the CubeSats. And the red dwarf, this is their rocket name, will be aiming for that. It will be a low earth orbit, you can see that, and it has a payload capacity of only 30 kg. But but the thing is, since it has a very less payload capacity, that means it will be able to provide dedicated launch services toward to the many of the CubeSats. Right now, Rocket Lab have the CubeSat market, but it has rideshare mission, because the CubeSats are around like 1 kg, 2 kg, 3 kg. This kind of yeah, is the weight of the CubeSats. And right now that is not, no one is aiming for such a small size and a small payload size CubeSat. So this company comes in for a 30 kg max payload, and let's see what they can do. Also the maximum acceleration for this also will be less than 5G, making it ideal for fragile payload. So yeah, that's the thing. Okay, and this is their team. The Sasha Deri is the CEO, and this is only a 7 people team. They are all managing everything, and that's why they are unable to, or I shouldn't say unable, but they are trying to set up the live stream. So that's why they are getting late with that, because they are just a 7 people team, and they are aiming to launch from the main launch site, which is very cold right now. The temperature there is -1 degrees or something, so snowy and everything, so it becomes difficult to do everything. So yeah, that's the thing. Okay, so this is the team they have the news, and now we can have a closer look at the rocket which is launching today. Okay. uh Hi everyone. If you have any questions, you can ask me. Yes, Balloon Chaser, it's a 20 feet rocket. Mario Miller says, greetings from Hamburg, Germany. Thanks for great work on your channel. Go on. Thank you, Mario Miller. And Bill Dodson says, good commentary. Thank you so much. It's 11 a.m. Yes, it should be. The countdown timer is right above. Let's see whenever they will go live. I'll switch over to their stream. But yeah, so let's have a look at the Stardust rocket now. This is their rocket which will be launching today. This is the maximum altitude is written as 4,000 feet, but they have optimized their configuration and their engine and everything. So right now they will hopefully achieve 5,200 feet, which means around 1.6 kilometers. That's the maximum apogee they will be able to achieve. So now you must be having a question: since they are not aiming for space, then how will they achieve a microgravity environment? Well, let me just tell you, when it is reaching apogee, right? Then the velocity decreases from something to 0 meters per second, and nothing is it is not in acceleration, right? So at that time the payload can experience a microgravity environment. That's how the NASA plane also works. There is one NASA plane, if you know, the which is actually used to simulate zero gravity environment. What they do is just they go up and then they free fall, and when they are free falling, obviously then you don't experience any gravity. So inside the plane, the members inside the plane experiences almost zero G environment. So that's what the concept here is. So you don't need to be going into space to experience microgravity, but yeah, if you are in an atmosphere, or there will be some aerodynamic forces which will play, but for some time near to microgravity you can experience. So yeah, maximum acceleration it will give is 2g, and payload bay diameter 14 inch, 8 kg is the side, and vehicle height is 20 feet. So right now you can see the vehicle is not very long. Okay, this is how it's look like. And you can notice one thing, that they have painted one fin blue in color. They have their nose cone in this, but they have painted one fin blue in color. And why do you if you ask me why they have done this, well, actually one of them answered this question. I asked them and they said that this blue fin actually is used to identify the rocket in snow, because that the launch site is totally covered in snow, and this is also a white rocket, so it becomes hard to see. But this blue fin will be able to identify them from a far location. That's what they say. That's why they have painted this blue. Yeah. Okay, so this is that. And talking about the engine which is having, they are having a MAREVL engine. That's what they say. They are having a MAREVL engine. And if you ask me what's the full form of it, well, it stands for Modular Adaptable Rocket Engine for Vehicle Launch. That's what they say. And it's a hybrid rocket engine, which means it will be using solid fuel as well as the liquid fuel. Uh, I mean, if you know Virgin Galactic, they also use this kind of thing, which they use solid as well as liquid fuel. Means the solid fuel is there and the oxidizer is liquid. That's what they do. And with this also, we the fuel is proprietary, so we don't know what is and what actually they will be doing. But yeah, that's the thing. Okay, the Iron Space Explorer says, will we get the KSP simulation? Unfortunately, no, for today's launch. I actually tried very hard to get it on time, but I don't think so. It was actually coming in all together. It requires uh, so much of effort, and it wasn't I wasn't having good time to actually make all those things and have a KSP simulation put up. So what I'll do is, no worries, whenever this stream ends and we have a launch, so I'll basically have a highlights with the KSP simulation. So that's the thing. uh, what class of the motor? Yes, I'm telling you. Any other thing? Nama Uru Science, yeah, the hybrid engine. Hi from Chill. Hi Martin. It's they are using a hybrid engine known as MAREVL, and we don't know what is the configuration of it. We just know that's the hybrid engine. That means solid fuel is there and the liquid fuel is there. That's mean, and most probably the liquid will be the oxidizer, because that's how they are able to control the throttle and everything. Okay, so yeah. And talking about their fuel, well, they are using a biofuel, and we don't know what fuel they are using, but they but they do have a igniter on board, which means they will be requiring an igniter to ignite both these two fuels. In one interview, their communicator actually said that you can store both the fuel and oxidizer separately, no worries with that, and it won't burst into flames like any other fuel would do, and does not require any special maintenance with the fuel. But you shouldn't store them in your location. That's what he said. I mean, I don't know whether is there any problem with the storage, or I don't know what's the thing, but one thing is for sure, that they require one igniter to ignite both the fuel. And what else? Yeah, that's pretty much it. So anything else what I have to do? Okay, yeah, the flight plan. What's their flight plan? Let me just have the flight plan for you. Just a sec. Here you go. So this is the flight plan they are having at t equal to 0. Means yeah, at the time of ignition will be there at t plus or 0, t equal to 0. Yeah, t minus 0, t plus 0 does not make any sense. it is written very correctly at t equal to 0. They will be having ignition, and the tower will be clear at t plus 2 seconds. So you can see it's not a very big mission. At just t plus 11 seconds there will be the engine cutoff, and with the at the time of engine cutoff it will be going at 2g acceleration, and then it will coast at the for the at t plus 21 seconds it will coast towards the apogee, and the separation will also happen at the apogee, and you will get 11 seconds of near microgravity, because at that time the acceleration is not there, just velocity is decreasing only, and that's how you are getting 11 seconds of microgravity. But you when they will like just separate the payload, obviously then the acceleration will be there with the decoupler, and the drogue chutes will deploy of both the payload as well as the this engine, means the booster, and those both the booster as well as the payload will have the main chute deploy and then the touchdown. So both the booster and the payload will be coming down with the parachutes on board. So yeah, and they do have two GPS on it, which means they will be able to locate where it went. Also they were like they are having some personnels already on the recovery site wherever they are expecting it to land, and they have a very defined area of landing, because since it's not a very high flight, and they can calculate what uh, where it could land. It's not coming from space, right? So yeah, also the wind factor does play a role, but uh, if for some reason they lost the visual contact, they can also use their GPS which is on board. So yeah, that's not a problem. With the recovery is not a problem with them. And then the payload bay will touch down at t plus 1 minute and 28 seconds. That's what their mission profile is right now. Okay. Good afternoon, everyone. Hi, Marcelo. Hi, Shivansh. Hi, Brian. Uh, so you can ask me the questions now. Then the propellant you are asking, we don't know. They have one secret biofuel, although we know the oxidizer, if I'm not wrong. Just a sec. It uses, if I'm not wrong, it uses, just a sec. G where have they, I don't remember right now, trying to recollect, but no, just a sec. Or guys, if you mods also, if you can get the updated or any update, just or anyone, if you get any update regarding the launch time, do post here on the chat. So yeah, the oxidizer which they are using is the GOX, gaseous oxygen. That's what we know. They are using the gaseous oxygen as the oxidizer and the super secret biofuel. That's what we know right now. And the last day they did one static, no, the cold gas flow test, which means they just actually flowed CO2 inside the plumbing of the engine to check whether everything is working right. And it was like a check for the plumbing, and it was a major milestone which need to be achieved for a flight today. So they achieved it successfully yesterday, and we do have a slow-mo footage of it. I'll just switch over to that if you want. I mean, yeah, we can look at that also, right? How tall is the Stardust one? Scott asked. Stardust one is 20 feet tall. That's what we know right now. uh Innovation in this rocket, well, this rocket is runs on bio-derived fuel. Okay, so that's, and why am I so excited with this company and this rocket? Because this will actually open new uh, you can say new type of engine, development of new type of engine, because the last time someone made a fuel for a rocket engine was a decade ago, and now they have made, because what the rocket designers, what they simply do is they firstly decide their fuel and then they design the rocket engine. That's what how the rocket designing works. Okay, but they didn't even have a fuel, so they literally started from ground zero. When they decided, when they actually made the fuel, they wanted to have some explosion properties with the fuel when they mixed with oxygen or what, and then they made a engine, entirely new engine would be developed for it. First of all, this is a hybrid rocket, which means there are not many hybrid rocket engine. Virgin Galactic has one, but not many hybrid rocket engine. Also, they are having some new type of fuel which no one has made yet. They have made this fuel and then the engine by themselves, without any help of anyone, which means they are just a team of seven. So yeah, kudos to them. That's why I'm really very excited with this company. Yes, Lee Foster, that's what we know. That's what we know, that it's made from sustainable materials found on farms, and so could be sourced from Maine. That's, yeah, that's the thing. Hi, hi George, hi Gwen. What is the microphone thing at the, that's microphone thing at the right is actually my goal, which that means actually, on if you are new guys here, on this channel I host live streams of every rocket launch that happens in the space industry, as well as the space events. Also, I have many space related videos to the space flight rocket engines and everything. So if you are that kind of people who want to have a one-stop solution for everything, this is the channel for you, Rocket Gyan. Do consider subscribing for latest updates. So yeah, that's what I do. So, and if you want to support me in what I do, you can check out the link in the description. There is a Patreon, there should be a Patreon link in the description. If it is not, I'll update it, and that's how you can support me. Although also there is that microphone goal which I am aiming for right now. You can see the audio quality is quite crappy right now, but yeah, that's what I'm aiming for if the goal is completed. So anyways, just a sec, just a sec. Are they live or not? No. And they are right now T minus 9 minutes from the launch. Okay, I'll switch over to that thing. Just a sec. uh just a sec. Whatever they have achieved, they have the static fires and everything, right? So let us just see that. Okay, and just a sec. uh okay, so okay, just a sec. Okay, so yeah, here we are. I'm switching over to the cold gas flow, which they tested last night. Cold flow test, yeah, the cold flow test with the CO2. So just a sec. Here you can see now. This thing really requires some fine tuning, but no worries. Just pardon me, guys. I am working on it. Where is it? And yeah, okay, got it. And Here you go. So this was the cold gas thrust, cold flow test which they did. Basically, in this test, they conducted last night, and they flowed. They used cold CO2 gas to flow through the engine and see whether the plumbing is all right or not. And yeah, so you can see how it went. So they just flowed the CO2. So that's what it is you are seeing right now. CO2 being flown through the engines. And it was a huge success. This thing was a success which guaranteed their plumbing is all right and they can go on with the testing. Okay, so they are live now, so we can switch over to that. But they are just right now. Okay, so yeah, they are live now, but right now they are just playing their intro. So whenever they are having that, I'll switch over to that. Okay, where is this thing? If you want to look at the static files which they did, I can also switch over to that if you want that. Maybe we can go on. Just a sec. How tall is the rocket? No, they have a stream now. Yes, I am switching over to that. Although the stream could be laggy, guys. I mean, oh,
Hi everybody. Thank you so much for joining us. Thank you for your patience. Let's see a couple of network issues there, but we worked through them and should have some amazing footage for you of onboard cameras for the flight of Stardust 1.0. This is a Blushift Aerospace live stream of the launch of Stardust 1.0, our prototype sounding rocket. This will be the first commercial launch here in the state of Maine, and it will be the first commercial launch of a rocket powered by a bio-derived fuel in the world. It's a really big day. Some of us have been working towards this moment since November 2014. And well, it's just a little bit surreal that the day has arrived. Thank you everyone for your support and well wishes. I'll make a couple of announcements and then answer as many questions as I can.
okay.
All right, so we'll start with the good news. Stardust 1.0 has been cleared to 5,200 feet, significantly higher than the initial 4,000 feet expected. While we still will not be setting any world records for speed or altitude, this will be a historic occasion. As mentioned, the first commercial launch in the world of a rocket powered by bio-derived solid fuel. And means first commercial rocket launch as well. We're launching from the Loring Commerce Center, formerly the Loring Air Force Base up in Limestone, Maine. One of the requirements for launch is clear skies up to apogee. And right now we are delaying because of weather.
Okay.
Skies should clear sometime between noon and 1. That's our hope.
Noon and
All
1.
systems are go on the rocket. Just ran final tests on the telemetry. So at last report from mission control, all systems go. Holding for weather.
So they are on a hold, guys, right now. That means I can update it. Just a sec. Hold. I
I noticed in chat someone asked if Maine is Canada. Haha. But in all seriousness, we are in basically a space race with Nova Scotia to develop small launch services to polar orbit. There's an effort here in the state of Maine we're proud to be a part of to build Spaceport Maine. One of the sites being considered is the Foreign Commerce Center for suborbital launch, and then for launch to a polar or near polar orbit. Of course, you need a coastal launch site for that with ocean overflight. Due south would be convenient. So Maine would be the perfect place for that.
Yeah, I actually wanted to talk
So
about
would
the
Nova
launch
Scotia.
site, but it's okay.
So we've got to get there first.
Okay, so if you get to know about the launch site, I mean, where they are actually launching it from, it's the from Maine, and it is really directly at the polar orbit. You can say location. It means that it's the best location to launch from for the polar orbit, and it's right in the coast also, so they can go on and drop the stages inside in the ocean. Although they can't aim for equatorial launches from that location, but they are not aiming for that either. I mean, the market which they are aiming for is the CubeSat market, and they want the polar orbits mainly and usually. So yeah, obviously that makes sense. Okay, so if you have any other questions, you can ask me and I'll see if I can answer. So we right now have a hold due to weather, and as he said that in between 12 noon and 1 it will be cleared. So that means we do have some time right now. Okay, and well, bio-derived solid fuel. Yes, the bio. Yes, you can say that it's the bio-derived. Okay, no worries. Camera feed will be up whenever they are go for the launch. Hopefully t minus 30 minutes until the launch. That's what I believe. I think so. I don't know. Or whenever they are ready to live stream that. Although just remember one thing, that there could be lag in the stream from their end only, because in Maine they don't have a proper connection yet. So let's see if they have managed all for today one. I don't know, but the yesterday's stream was a bit laggy, so let's hope that it's not laggy today, and we get a proper feed. As he mentioned that there will be a feed from the onboard camera also. So wow, that would be pretty amazing to see, right? I mean, the onboard camera view for a snowy location, we haven't seen from a very long time. So it will be a very good thing to see. Let's see what whenever we get it. Hi everyone. Rob says, do you provide launch streams for Kerbal contraptions? Well, I do provide my live streams with the KSP running as a live simulations of the event. That's what I kind of do. But for today's one, since it was at a very short notice, so I wasn't able to develop one. But maybe the highlights could have those things. So do look out for that. Uh, Hi Thomas, that's what your name is, right? Let's hope everything goes according to the plan. And anything else, if you have any other question, you can ask me, guys, and I'll see if I can answer them, and I'll try to answer them then. Is there a video feed for this? Ayan asked me, right? Yes, there is a video feed. If you want, you can check that out. That's not a problem. I mean, the video feed, I mean, this is what they are having right now, and whenever they have a video feed of the rocket, they will be that will be seen here only. So don't worry about that. Okay. Show us the static fires. Maybe I can do that. Just a sec. Yeah. Here we go. Okay, okay, I can do that, but let's see. Just a sec. Hyped for SN9 Carbodine says, yes, I am really very hyped for that. And I mean, whenever that happens, although there will be a delay with SN9 launch, because as Elon mentioned, they require some fix with the two rocket engine. That means the last time they had to switch over the engine for the SN8, it took around 26 days. And now they have two engines. So maybe they can take a month now for the SN9 to fly, but we don't know. So yeah, and if you want to support me, what I do and what I do, you can do that by becoming a Patreon, as well as um, if you want to give a one-time funding, the super chat is always enabled. That really helps this channel to stay alive, because yeah, it really takes a good amount of time from me to host every live stream, so you know actually how many rocket launches happens in the space industry and space events. So yeah, your help, your support is what drives my motivation and this channel. uh oh wait, we can look at we have a hold on the weather. Maybe we can look at the static fires. Just a sec, I'll switch over to the static fires, guys. Mm, here we go. So this looking good. Oh, oops, 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 oops. Uh, and yeah, this is the static fire which they had. Okay. We'll get another view also. fine. We can have a look at it again. I mean, I liked it very much. I can, yeah, we can have a look at it again once. So this is what you can get from a bioderived fuel. Wow. Okay, this was the static fire. Although you can, they said that they weren't able to have a CO2 flush, like when they actually use it before after the static fire. So yeah. Yes. Okay, just a sec. Yes, you can donate through super chat. Whoever asked me Roblox memes, you can donate through super chat. Although I have a Patreon link also. Just a sec, I'll update that in my description. Then I forgot to do that, but yeah, right now you can always do super chat then. Yes, that one guy. The launch is on approximate hold right now, and let's see what we get. If you have any other questions, you can ask me for that, and I'll see what I can do with it. Maybe we can have a look at another static fire because they did that. Just a sec. There you go. Right now. Okay, sir. Done. So I have updated the link in the description, so you can refresh the stream and you will get the link if you want that. And now we can have a look at their static fires and what they did actually with their other rocket. Or maybe we can have a look at their other rockets. Yeah, that would be great, right? Rather than looking at the static fires, we can have a look at their other rockets. Thanks, Blues Traveler. That's the link. Yes, thanks for posting it. How tall is the rocket? This is 20 feet long, and yeah, we can have a look at the just a sec. Their rocket lineup again. That would be great, right? Till they go live, then at that time we can have a look at their rocket lineup. So this is their rocket lineup. So if you have just joined in and you don't know what is with this, and don't worry, you won't miss any update from them. That's running in the background, so whenever that happens and whenever is the footage we get, I'll switch over to that. So till that time we can have a look at their rocket. So today they will be launching the Stardust Gen 1 rocket, and in all these rockets the engines is hidden. Have you seen that? The engine is totally hidden because we don't know what is behind these engines, right? So yeah. And this one, the Stardust Generation 1, you can see here it achieves around the maximum altitude will achieve is 5,200 feet, and it is ideal for student and budget payload. So this is a sounding rocket. They want, as the commentator on the stream, the actual stream also said, they won't be breaking any speed records or height records. They are just doing it as a technological demonstration of of around 6 years of hard work. Whatever they have done on this rocket, they will be able to see it go live and go in flight today. So yeah, the payload bay diameter is 14-inch, and the maximum payload it can carry is around 8 kilograms. So, and the number of stages it has, it's one only. So yeah, that's what it is. Now we can have a look at the another rocket. Just a sec. How do we backspace? Okay. Yeah, the Stardust Gen 2. This rocket is okay. So they have the views from the rocket. I'll switch over to that. Don't worry. Hmm. And there you go. So the footage is a bit grainy, and it is bound to happen because there the internet connection is not very proper. But yeah, footage is bit grainy, which you can see right now. But don't worry. Oops. You won't miss anything. Yeah, so this is the live view of the rocket right now. It is standing on the launch pad, and the launch pad which you are right now seeing is the launch tower basically, and it's a mobile launch tower, so you can actually take this thing to any location you want and launch this rocket from there. So yeah. And says the Virgin has also planned. Virgin has plans as well. Yes, Virgin. First of all, the Virgin Orbit is aiming for a launch tomorrow, I guess. And the Rocket Lab is also aiming for a launch tomorrow, and I'll be live streaming that. No worries, and I'll try to integrate KSP also. So yeah. The launcher one, yes, the John says the launcher one. Also, the Virgin Galactic is you also using an hybrid engine, and this Blushift also uses a hybrid engine for this rocket. So yeah. Sukasita says, oh, this is interesting, never heard of anyone mentioning Blushift before. Thanks for hosting a stream, and thank you so much for your support. That's what I'm here for. Time, ignore the timer, okay? This is not a suborbital test, Maxine. This is the rocket will be remaining subsonic for all the time, and the maximum apogee it will achieve is around 1.6 kilometers. If you guys want, we can now switch over to their actual stream. I mean not stream, but the rocket lineup. If you are interested in seeing what rockets they have, and what they have and what they will be developing. What weather do they need for the flight? They need a proper weather, and the commentator, as he said, they need clear skies at least till that apogee of 1.5 kilometers. So
If you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0. Fully integrated rocket on the launch pad in the foreground here. And we've got some news about the weather. It looks like the forecast is not improving at this point. So the odds of launching
okay.
by 1 p.m. have just gone down. Just holding tight for weather.
Okay. Let's hope the weather cooperates with them and they are able to launch it properly today. So let's hope they are able to launch it. Let's see what happens. This is a rocket solid fuel or liquid fuel. This has both liquid as the solid. And not the liquid, actually the oxygen which they are using is the gaseous oxygen if I'm not wrong, but the solid fuel is the solid one.
All right, so a couple of sources indicate very decent chance of launch at 1 p.m., but there doesn't seem to be general agreement across sources.
Okay, no worries, we are
Higher rates of agreement between sources that weather will clear up just before sunset. So we might be here a while. But of course, this is Maine. Weather is unpredictable, and sometimes that can mean a lucky break. So we are all systems go, but holding to launch due to weather.
Okay. Well, he said that some sources indicate a decent weather and some does not. So we need to wait at that time only at till that time around. He said noon to 1 p.m. So we need to wait at that time and see whether the weather improves or not. So I'm really hoping that they don't have a scrub at least due to weather. Also with this thing, since it will be remaining on thickest part of the atmosphere, so the weather actually plays a good amount of role with this thing. Also they are not having any roll control or roll stabilization with this thing, although the engine has gimbal, but roll control right now they are not having. And here we go, there's one guy checking onto the system. Maybe let's see what he is doing. But yeah, so what I was saying is the atmosphere does play a good amount of role, so they need to have a good weather in all its flight, because they will be relying on the parachutes for both the engine, the booster, as well as for the nose cone or the payload. So the touchdown will be with the parachute, so hence they need to have a good weather to rely to actually have everything on place. Yeah, also this guy which you are right now seeing gives us a scale how tall this rocket is. So yeah, it's not a very small rocket though, but not a very large also. I mean, four of the guys standing on top of each other will measure to the height of this rocket. So yeah. Since this is also not going into the orbit or space, so yeah, we don't actually require it to have a bigger size, but yes. Did he just release the launch clamps or what? That's interesting. Let's see what we get actually. No worries. I actually really wanted this you can say, I really wanted to have a KSP simulation going on with this thing, but due to this short notice I wasn't able to develop it. But yeah, you can't fit in, yeah, obviously you can't fit inside a human, I suppose, in this rocket. But I was saying actually the size, the height of this rocket, that's what I was comparing to. Maybe, I don't know. Okay, so this is the views which you can right now seeing, and maybe we can have a look at the again now the rocket line up. If you guys are interested, just put me in the comments on the chats, and I'll let you guys know and see what is their rocket lineup. So you can also see that the weather is very snowy there, and that means uh, this thing will be launched in snow, and there are a team of only 7 people managing everything, and that too working in snow. So hats off to them, really hats off to them. Mods, please take care of the repeated questions if anyone asks them, okay? And he's certainly tinkling with the engines right now, maybe. Okay, good. Not about, not really 4, but 3 will suffice this height of this rocket, right? The speed of the rocket will not exceed Mach 1, and yeah, that's what they said. I mean, they are not aiming for any record breaking here. They are just uh, literally aiming for technological demonstration. Like, yes, you can actually fly a rocket to a certain height, or maybe to the space, with just a bio-derived fuels. So that's what they are right now demonstrating. It's strange, kind of strange, but the rocket fuels are maybe this is not fueled yet, all or maybe the fuels are extremely safe to be uh, going around the rocket at this time if it is fueled up. Stray fox, yes. Could be there, maybe there, and if I remember, they are very close to the highway also, so we don't know actually. Engine is hybrid, gaseous oxygen, and the fuel is solid, and that solid is fuel we don't know. That's a their secret fuel. No, not methane, a biofuel. Bio-derived fuel, which means actually what they mean by bio-derived fuel, that is not derived from cow dung or something like that. Maybe you can get methane from cow dung, but no, that's not the bio-derived fuel which they are talking about. They are actually talking about literally fuel which can be derived from the farms which are in Maine. Okay, and here you go, the holding due to weather. And so the fuel is a solid fuel derived from the farms, so don't know. थैंक्स गौतम. आशा करते हैं भाई. Maybe they can well, they do not actually require a self destruct for this thing, because these two fuels, I don't know whether you can see the height of this rocket, and the size of this rocket is not very huge, that if they do require a self-destruct option, maybe it can just crash onto the land and there won't be a big explosion. But one thing which I am mm, actually thinking is they are using gaseous oxygen, that's all right, and a solid fuel, and they are actually they they don't both ignite in just one contact. They need one igniter also. So I don't know whether will there be an explosion also or not. So we don't know that. I know the I have actually uh, okay. We don't know about the fuel, whether what is it's from. Main standard biofuels.com. Okay, so there's a good website, you can see what is this all about.
All right, if you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0, world's first commercial launch of a rocket powered by bio-derived fuel, and the first commercial rocket launch here in Maine. Currently, we're holding for weather, waiting for the sky to clear. Looks like the outlook is a little bit brighter for noon to 1, so holding tight, fingers crossed for a launch at that time.
Okay, so yeah.
Here, Dodge 154 asked, is this just going to be a sounding rocket, or will it eventually launch payloads? Good question. Well, this is a sounding rocket. It's about 20 feet tall, about 600 pounds fully fueled, and it's going to fly much lower than the vast majority of sounding rockets, however. So we're going to reach 5,200 feet above sea level, and sounding rockets can go anywhere from tens of thousands of feet to hundreds of miles, depending on the mission. So we won't be flying a kind of a normal profile for a sounding rocket, but it is a suborbital trajectory. Now, as we scale up, we do plan to develop Starless Rogue, a two-stage suborbital vehicle that can lift 30 kilograms to 150 miles. And also the Red Dwarf three-stage to low Earth orbit.
Okay. Good info out there. And yeah, the last the rogue rocket which he was actually telling you all about is their actual orbital class rocket, which can launch 30 kilograms satellites to space. So yeah, that's what it is. What's the purpose of this rocket right now? I don't see any purpose. I mean, we do see any right now there is a purpose, but once they have achieved this flight, and okay.
GJ840 asks, why use a hybrid instead of a liquid? Wouldn't it be much easier to scale and be more efficient in general? Excellent question. Well, I shouldn't pretend my area of expertise is in liquid-propelled rockets here. But I would argue that we're shifting the efficiency around to production, and also only having a single set of plumbing in there for the oxidizer. There's fewer moving parts, it saves you weight, fewer things that can fail. So there's a lot of advantages. We don't have quite as fine of a control on throttle ability with a hybrid, but still enough that if you were to cluster the engines in a stage, you'd be able to steer the rocket through differential throttling.
And yes, that's what is gimbling is, and it is capable of gimbling. And with the as he mentioned about the clustering, with the rogue rocket, which is the orbital class rocket, there will be a cluster of the rocket engines which this is having. So that could be actually seen as a technological demonstration for a bigger rocket in future. this rocket does not have any right now. This rocket is used for technological demonstration, as well as it has two payloads in it. One is CubeSat from Pearl, I guess, and there is one commercial and there is one student payload in it, and they will be testing the harsh conditions of the launch. Maybe, I don't know yet. They haven't released anything official yet, but
Too
yeah.
Far North asks, would the lowering location be of future use? And there's actually kind of a long answer there. There's an ongoing effort spearheaded by the Maine Space Grant Consortium, of which we're a proud affiliate, and certainly a stakeholder in the effort as well, to develop a spaceport here in Maine. Now, a number of sites, last I heard at least, were still under consideration. But there was a thought of launch control and business incubation and maybe payload integration, like a clean room and stuff, and data storage and processing down in Brunswick. Suborbital launch, either here in Limestone or based out of Limestone, depending if it's horizontal launch, like what Virgin Orbital is planning to do, or what Pegasus did, or vertical launch like what we're doing. And in theory, if permitting allowed, you could also do horizontal launch out of the former Brunswick Naval Air Station. And then also there's a call for a down east coastal launch site for launching due south with ocean overflight to polar and near polar orbit.
Okay, yeah, the launch, okay.
Now, as for how the idea is progressing, it was considered as a bill in the last session. Maine's Idea B committee voted unanimously and with bipartisan support ought to pass on LD 2092, the bill to create a Maine Spaceport Leadership Complex. A Leadership Council. Now, the bill never made it all the way to the floor as the state government kind of pivoted to focus on coronavirus. So I don't have the most current information on where we go from here in terms of state politics. But we did recently receive a sizable grant from the EDA to put together that leadership council, among other things.
Okay, so they are getting some investment. That is really cool, because the thing which they are doing is extraordinary, and they need really, like as they mentioned, they have invested $500,000 on the rocket development from their own pocket. And if you guys want to support them, you can head on to their website and become a Patreon there also. So yeah, it's 20 feet tall, yes, blue Stavrer. And Martin, what I actually meant from commercial and student, that the payload is one payload is commercial and one payload is student made. So yeah, that's what I actually meant. And the launch site, yes, the launch site, if you will search the Google map and see the launch site of actually the Maine, where Maine is situated, then you will actually see that it's situated on the northern coast of the US, and from there you can actually launch rockets into a polar orbit very easily. And you will not require any as such a problem with the stage dropping,
And
because
just
you
dropped
can
a
just
link in our chat to a Maine Biz article on the Department of Commerce or Economic Development Administration grant to the Maine Space Grant Consortium. Excellent opportunity for some light reading as we wait for clear skies.
Okay, so mods can they just spam that link here if you can get that. Hmm. When could that hold end? We don't know actually. Um, it's 10:30, which means 12. They actually have around 1 hour from now, approximately 1 hour from now, for this thing to get launched. And whenever the weather clears up, they'll go in for the countdown. So let's see. Exactly. And their site is in the coastal region, so they can drop their stages in ocean. So in the meantime, we can have their look at their other rockets which they have. This is the Stardust Generation 2 rocket, and it will achieve a maximum altitude of 40,000 feet. Well, that is pretty much large. Around it will be around 12 to 15 kilometers. This will achieve that maximum altitude. Maximum acceleration will be 5g. There is no spin stabilization, and the maximum payload it can carry is 30 kilograms, and it's just 1 feet, and 21 feet is the vehicle height. So you can see that I don't think so there is any other changes with the Stardust Generation 1 and Generation 2. Maybe they have, we know this thing is large for this one, but other than that, I don't know. Maybe they have larger fuel tanks with it and better thrust engine. Let's see. So this is an upgraded testbed over Stardust Generation 1 for those experiments needing higher velocities through the atmosphere and longer flight times. Ideal for students and researchers needing to gather data in a launch environment for development purposes. Well, yeah, actually you can get a sense of launch environment when this thing, the payloads could be launched in actual rockets to the orbit, because it can simulate that environment, because this thing can go on to a suborbital flight with a maximum acceleration of 5g, and that's the standard for most of the rockets. So yeah.
We see a couple of questions about cameras on board the rocket. Happy to say we've got 5 cameras. They're not on right now. The payload bay is powered down to save precious battery power. But we should have some really good footage for you guys through the flight.
That's what we are waiting for, right? Let's see what we get. Plants, Julian says plants. I suspect that could be the
Harris,
candidate.
Asks a shout out to MSSM students. I myself am a proud graduate of the Maine School of Science and Math, just a couple minutes from our launch site here. So hey guys, hope you're having a good break. Hope you're keeping safe and healthy. And I'm sure that nobody has to tell you this, but study hard.
Exactly. Okay. Okay, yeah, now we can have a look at their rockets. Yeah, this was the Stardust Generation 2 upgraded version of Stardust Generation 1, which you are right now seeing. And
Mindvent asks, how high are we going today? And the plan is to reach 5,200 feet above sea level. the maximum altitude was previously 4,000 feet. That was more of a permitting issue than a mechanical issue with the vehicle.
Oh, that's nice. It's a
We got cleared to the higher altitude for a couple of different reasons, but chief among them was just making sure that we burned through all the fuel during the main engine firing.
Yeah, because that also makes sense because as he mentioned, they don't have right now any throttling
There's a little bit of static on the feed.
capability.
Sorry about that. We're piping sound through an FM transmitter for specially invited guests or tuned in their vehicles from a safe distance on the south end of the runway. We've mitigated the buzz as much as possible. There's tons of coils and ferrite beads here in the studio. But at the end of the day, we've got an FM transmission and a live stream coming off of the same source. There's going to be just a little bit of a buzz. Now, depending on how this launch goes, and depending on how our next round of capital goes, we may be able to resolve that issue for our next launch.
Okay, cool.
Graham Edwards asks if we aspire to orbit for 2021. Sure, that would be amazing. I think we'll be pretty proud of ourselves if we make orbit by 2024.
Okay.
This year, assuming that the mission here goes nominal for Stardust 1.0, the focus moves to Stardust 2.0, which will reach higher altitudes, go through a more intensive permitting process. And lay the groundwork for the two-stage suborbital rocket Stardust Rogue, which will basically just use a Stardust 2.0 as the upper stage.
Okay, that is cool. I mean, yeah, after the successful launch of the Stardust 1.0, they will move on with the Stardust 2.0, and as they mentioned, they will be really proud if they can manage to get orbital rocket by 2024. Still 3 years to go, and the rocket developments take time, as we all know. We are actually seeing up close one of the rocket development, that is the Starship, and that is being made by SpaceX, which is known for its fast transition to everything, and that is only taking time. So these companies who don't have proper investors also will take time for sure. So yeah.
My God, is that NASA spaceflight in the chat? That's amazing. Hi guys. We're big fans. Probably no surprise.
Blushift's plan for reusing their rockets. Right now they don't have any reusability plans, but since right now they don't have, right now they just want to reach to the orbit. First of all, this flight should be successful, then the Stardust 2.0, then there this rocket, the Stardust Rogue. Okay, let's have a look at this rocket, which could be the third flight. I mean, which could, yeah, eventually be the third flight, which you can see also from the looking very interesting. Maybe from the figure which we are seeing right now. Okay, so if you don't know, this rocket will be going to space in a suborbital trajectory, but suborbital flight, and a longest 0G time of around 6 minutes. So yeah, will be pretty epic. The maximum altitude it can achieve is 150 miles, and that is so good. Around, I don't know how much it is around in kilometers. I will have to do the math, but seeing from the rocket, it looks like they have four strapped on, I mean four clustered boosters which they have in the Stardust 1.0 for as the base stage, and then this is the second stage they have for the suborbital one. Maybe that is the case because we can see the dimensions of this pipe kind of a thing, and they match with the upper stage, and it looks like the four of them are strapped on together to make one booster stage, and then finally the upper stage. So the payload capacity of this is around 30 kilograms, and yeah, it will, this rocket will prove to be a very good one because of this, the maximum 0 G time around 6 minutes. That is very cool for New Shepard. Also, that is not the thing. I mean, they have a 0 G time of around 2 to 3 minutes, I guess, but this is the maximum they can achieve. So yeah.
If you're just joining us, this is a Blushift Aerospace live stream and FM transmission of the launch of Stardust 1.0, Maine's first commercial launch and the world's first commercial launch of a rocket powered by bio-derived fuel. We've got 3 customer payloads aboard. We're ready to demonstrate our proprietary bio-derived fuel in flight and show also the growing demand for these suborbital flights. We've got a couple updates about weather and a new timeline. Looks like our best chance for good weather is going to be between 2 and 3 p.m.
Oh god. Okay.
I'll say here it's a 50-50 shot. We don't really know what it's going to look like at that point. So with that in mind, the plan is to begin the oxidizer tank fill at about 1 p.m. Call the FAA to give our 1-hour notice. And weather permitting, we'll launch between 2 and 3 p.m. Now the outlook is, given what the weather looks like for the rest of the day, if we have to abort the launch, it's probably a scrub, and we would probably be looking at a new launch date early next week.
Okay, so right now they're aiming for around 2 to 3. They have changed their time. That means we do have a lot of time then.
For folks in other time zones, 2 p.m. will be just over 2 hours from now.
Okay, so yeah, 2 hours from now. That means we do have a good time until they launch. Let's see what we get then.
Someone in the chat asked our FM frequency. It's 92.9 FM. There really isn't not much distance on that, so unless you're on the south end of the runway, probably live stream is your best bet.
Okay. Oops.
So Stardust 1.0 is a single-stage vehicle. It will, however, split into two bits. You can see our launch sponsor, Rocket Insights. You can see their logo on the lower half of the vehicle. There's a line right above it. And that horizontal line is where at apogee Stardust will split into two sections connected by a tether. A drogue chute will come out, and then main chute will deploy roughly 1,000 feet above the ground.
Okay.
Someone asked, Hyder, does the company have a Patreon? Why, yes, we do. You can look up Blushift Aerospace and Patreon, and I'll drop the link in just a minute.
Well. Okay, so we do have a good amount of time now, and let's see what we get actually. Jean Thomas, it's around 4 a.m. in Australia. I mean, yes, you can go to sleep, but this kind of actually, I am very lucky with this launch. It's being at this time, because otherwise the launches which
I saw somebody asked about our payloads. Glad you asked. We've got 3 of the 3 available spots. All were filled, and we're already starting to book client payloads for the flight of Stardust 2.0.
Okay.
So Falmouth High School is an excellent representation of kind of an academic customer. Falmouth High School here in Maine worked with the University of Maine and the University of Southern Maine to outfit their CubeSat prototype with a GoPro radio transmitter and Xenobox chips to collect flight data, including acceleration, pressure, temperature, and humidity. Not directly related to this mission, but congratulations are certainly warranted. Falmouth High School also helped develop the imager payload that will fly aboard MESAT-1, means first CubeSat, or first orbital CubeSat. They're still called CubeSats even on suborbital missions. Certainly they're not satellites, but the form factor is kind of convenient in how standardized it is. So Falmouth High School's imager payload will fly aboard MESAT-1, first orbital CubeSat. Imager is specifically modified digital camera for imaging shallow coastal waters to distinguish water quality properties such as turbidity and concentrations of phytoplankton.
Okay. Okay.
Another payload will be from Kellogg's Research Labs. These guys are a really good example of an industrial client. So aboard their CubeSat enclosure, Kellogg's Research Labs is going to be testing the vibration dampening properties of nitinol, a shape memory alloy of nickel and titanium.
Yep.
They're going to test its behavior in the conditions of a rocket launch, specifically looking at how the shape memory alloy can take vibrational energy and turn it into heat energy, potentially dampening shock for systems aboard a CubeSat.
Okay. So Blue Straddler
At this point in the game, Kellogg's is certainly no newcomer to aerospace. They've supplied parts for more than 100 satellites launched in 2019 alone. So we're really excited to have them flying with us and testing a new application for this material.
That is really cool, actually.
And our last commercial payload comes from Rocket Insights, software development company. They will be filling their CubeSat enclosure with traditional Dutch wafer cookies called stroop waffles as an homage to their Amsterdam-based parent company, Dept.
Okay, so Blue Traveler has given one
Now,
link
the
of
plan for this mission was to have a camera in the payload bay, no matter what. But when we realized that there were going to be stroop waffles flying in a pseudo-microgravity environment for about 11 seconds, we worked really hard on that camera in the payload bay.
Okay, very cool insights we are actually getting from them.
So if all goes well, sometime between 2 and 3 p.m., you'll get to see some stroop waffles in microgravity.
Oh, wow. That could be great. Let's see what we get actually. I really want now this thing to fly and we get to know and see actually how does this work around. Yeah, I was telling about the biofuel which Blues Traveler have posted. I'm not actually sure about actually whether that's the fuel which they are using, but yeah, that's a biofuel which someone has made. I think it's from, I don't know, maybe from Chinese officials, but yeah, someone has made. But we don't know actually what biofuel they are using. If you know, that is pretty epic then. Yeah, we can have a look at their rockets now. Okay, so yeah, we were looking at this rocket, the Stardust rock, and this is a two-stage rocket with the maximum acceleration of 5G and payload bay diameter is 24 inch. So it's a you can see that right now the rocket which you are right now seeing has the payload diameter of around 14 inch, and this one has 24 inch. Okay, so that is great. It's a two-stage rocket. Maximum altitude it achieves is around 150 meter, used for hypersonic testing by reaching velocities of Mach 6 to 7. So yeah, it will be a cool rocket no matter what. And then finally their main orbital class rocket which everyone is aiming for now actually. They are this red dwarf. So here's the image of the red dwarf which you can see right now, and it's the three-stage rocket, and it's a bit glitchy here, but yeah, here we go. So this is the first stage, this the second stage, then the payload adapter most probably, then the third stage, and the fairing. Red dwarf is a low earth orbit launch vehicle tailored to meet the needs of a nano satellite launch community. Yes, and because it can fly only 30 kg to the space, and that is pretty epic because no one is catering to this market. Many people are actually going in for small sat market, but the nanosat market is also really very expanding because nanosats are more cheap to make than the small sats. So yeah, obviously they will be cheap. So and it has a launch acceleration of less than 5G, so more fragile satellites can also go into this rocket, and it will be placed into the orbit. So vehicle height 78 feet, number of stages is 3. That's all we know. That's all we know. 24 inch is the payload bay diameter. Time in microgravity months to years depending on the orbit which it has put into. Also the capability of the CubeSat, whether it has any propulsion on it or not. So yeah. Cool, really cool. And from here we can see that with the second stage they are having maybe one, two, three, four, five engines, or no, they can't be having 10 engines, right? maybe 5 or what for all these stages. I don't know much about this, but yeah, this is the red dwarf rocket, which is which they are aiming for an orbital flight. Yes, it is a smaller rocket. So since you can see the payload capacity is also at 30 kilograms, don't see that it's a smaller rocket and just a payload capacity of 30 kilograms. That's not how it works actually in the CubeSat market, because there is a CubeSat market no one is looking at right now. Rocket Lab is there aiming for CubeSats as small sats with a payload capacity of 250 to 300 kilograms, but these one has actually aiming for nanosats, which are around 1 kg, 2 kg, 3 kg in actual mass. So yeah, this is a different type of rocket. Okay, I don't know whether I can play this music or not. That's a good info from the Blues Traveler. Friday's rocket launch will carry three payloads, a special alloy that a New Hampshire company wants to test, a project created by Falmouth High School students that will use sensors to record atmospheric conditions, and a company that for its own reason has a package containing tourmaline and some containing tourmaline and some stroop waffles. So that's what he said, and they have a camera on board for that. So we'll get some views of it. Let's see what do we get then. Guys, if you yes, 78 feet tall, because it's an orbital class rocket. This thing is only 20 feet tall. Stardust 1.0. Not exactly SpaceX type rocket. SpaceX has the Falcon 9 of SpaceX is kind of really very huge. I mean, yeah. So guys, if you want to support me, the link is down in the description for the payload for the Patreon, as well as if you want to have support this channel by giving one time funding, the super chat is enabled for that. And if you don't know what I do, I host live streams of every rocket launch and answer your questions, uh, and maybe have some KSP simulations also. But for this one I wasn't able to prepare it because this launch was on a short notice. So yeah, let's see. And yeah, so in this channel you will find various rocket launches, space events, and other space related and space flight and rocket science related videos. So you can consider subscribing if you want, and support me on the endeavor of spreading the space news, space flight news to everyone. It's 2 to 3 p.m., right? So let's see how does it work. How much does this rocket cost? We don't know, Fox fam. We don't have much info about this rocket because this is a very new rocket here, and yeah. do they have a backup date? Aaron says yes, they have a backup, not backup date exactly, but the next week they aim to launch this thing if they miss uh, the launch today. Hmm. Okay. Guys, I think there is a lot of time. I think I can have my dinner for some time, and yeah, you can, I'll have the stream on, no worries, you can look at the stream, but maybe I'll have to go now to eat something. Okay, so I'll be back in some time.
Scrap Over Engineering asks, what was the name of the Amsterdam-based company which sends the stroopwafels? I believe it's Dept. Delta Echo Papa Tango. Dept. A couple people from Rocket Insights came up to watch the launch, and some of them are even helping direct traffic, which was just amazing. Really, really like, just fun people. There's some questions also in chat about the reusability of the vehicle. Stardust 1.0, of course assuming nominal flight parameters, is fully reusable, save for this tiny little kind of tined collar of metal down at the base of the vehicle. It almost looks like the back of a jet engine, but it's not. Its purpose is twofold. First of all, it's a little bit of a crumple zone during the litho braking maneuver. The MAREVL, or modular adaptable rocket engine for vehicle launch, is going to split off from the payload bay, and they'll descend tethered together, and then once the main chute comes out, the engine will touch down first. This means that the payload bay will have several seconds of additional deceleration for a softer touchdown. But when that MAREVL touches down, it just seemed like a good idea to have something to absorb shock.
I mean, yes, they do have put some thought on it.
So those tines will probably crumple a little bit, and we'll switch them out for the next launch.
Okay, so that's the reason why you are not seeing the engine.
Now, the other purpose of those tines is to help keep brush away from the engine nozzle in case it still is warm. That engine should be very thoroughly cooled by the CO2 flush after main engine cutoff. I say main, of course there's only one engine. After engine cutoff. And also the air 5,000 feet above Limestone Maine, I'm sure, will do a terrific job of cooling the engine. But in the event that it touches down hot, those tines will also, crumpled or not, just help keep stuff clear of that nozzle.
So it does have a good job.
Anyway, that one component isn't reusable, but everything else, if the flight goes to plan, will be.
That is pretty epic.
Now, down the road, as our rockets carry heavier payloads and they go higher and farther, reusability is very much on the drawing board. Can't go into any specifics here. But if you want to do new space at this point, you pretty much have to be thinking about reusability, and that's a good thing.
Hi, Lucien Muzza from Brazil. Hi, Lucien, if I've pronounced your name correctly. So yeah, that's a pretty good thing. I mean, I was wondering, I had this thing in mind that maybe that is for crumple, but I didn't say it because I wasn't sure properly. So, but yeah, now as he mentioned, so yes, that is a crumple zone, which means actually since it does not have any landing legs or something like that, right? So whatever weight it will carry, it will directly, if that crumple zone is not there, crumple metal or is not there, then whatever speed which it is coming down will all be taken by the engine, and you don't want the engine to be damaged, because obviously the engine is very costly and requires some good amount of engineering to make, as well as some good amount of testing. So you need to save that. So to save that, this is there is a area called this crumple metal, which you can right now see in the, looks like a jet engine just beneath the rocket. And the purpose of this is to absorb the shock when it comes down and lands on the earth. So yeah, and another reason is also to avoid the if the engine is not cooled down, and to yeah another reason of that was, as he mentioned, if the engine is not cooled down, it can then hit the snow, and there could be cracks in the engine, if I what I understood from what he said, actually, because there will be a rapid cool down if the engine touches the snow. So yeah, we don't want that also. So yeah, that's a good insight which we actually got to know today. I mean, yeah, why not? They must be having a crumple zone for absorbing the shock. But uh, yeah, yeah. Not exactly, Jim Joy. The flight itself is a low altitude, but the rocket is right now not capable of orbital flight. This is not a rocket is not capable of orbital flight at all, because this is a small rocket right now. But they do have a orbital class rocket in plans. Probably in 2024 they will be launching towards the orbit. Yes, greedy capitalist. So yeah, I'm right now actually very hooked to these kind of launches and everything. That's why I wasn't going and listening to it, but now I have to go and eat something. So yeah, enjoy the stream. Maybe I could come in between to say something. Yeah, okay. Oh, my mic was muted. Okay, so I was saying, no, did you listen right? I muted my mic right now. I forgot. Okay, sorry.
If you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0, our prototype sounding rocket. This marks the first commercial launch of a rocket here in Maine and the first commercial launch of a rocket powered by a bio-derived solid fuel in the world. Currently, we're holding for weather. We'll be flying to 5,200 feet today and need less than 50% cloud cover at that height. We were previously cleared to 4,000 feet. Got it bumped up to 5,000, but it sounds like there's pretty steady clouds everywhere above 2 for now. There's a good chance that the weather will clear up between 2 and 3 p.m. If that doesn't work, then the chances are we're going to scrub for weather and reschedule to next Tuesday or next Wednesday. All right, in the chat on our live stream, I see some folks questioning why one would launch from Maine, specifically referencing our, well, I guess what you could describe as excessive latitude. Now, it's true when you go to orbit, the closer you get to the equator, you get kind of a bump from the Earth's rotational speed. And it'll shave about 1,000 miles an hour of delta V off of what your rocket needs to do to achieve orbital speeds for an equatorial or low inclination orbit, proceeding from west to east. If you launch from higher up, then you need to spend more fuel essentially going sideways until you achieve such a great sideways velocity that the ground curves away at the same rate that gravity pulls you down. Thus, you achieve orbit. So, why then launch from a high latitude? Well, for a high inclination orbit, such as a polar orbit, where you go over the South Pole, either perfectly or very nearly, and about 45 minutes later, because low Earth orbit, right? 45 minutes later, you're halfway around the world at the North Pole, another 45 minutes back at the South Pole, while the Earth is rotating under the satellite. It's a terrific orbit for communications, for Earth imaging. And so for an orbit like that, you need to cancel out the Earth's rotation. So if you're trying to reach a polar or near polar orbit, launching from the highest latitude possible, either as far south or as far north as is reasonable, gives you fuel savings. Basically the same kind of fuel savings you would get if you could launch comparably close to the equator for a polar orbit at the same altitude. So with Maine's high latitude and south-facing coastline, in down east Maine, you've got about 1,800 miles of ocean over flight. So it's a safe and efficient way to launch to polar and sun-synchronous orbits, while still contiguously connected to the United States eastern seaboard. And with some really terrific accommodations. We are vacation land. We're also going to be rocket land, though. The future of space will be made in Maine. Gaming Cube 47 asks, when are we planning to reach space? On purpose, I assume. In all seriousness, in about 2 years, we, if all goes to plan, we'll be launching Starless Rogue. That's our 2-stage suborbital. And that can get up to 150 miles, so well above the Kármán line. And so, first flight of Starless Rogue, that'll be when we reach space. Jan Piotrowicz asks, how big is the team that made this rocket? Between employees and interns and contractors, at any given time there was probably about 10 people, give or take, working on this project over the past 6 years. Cost of Stardust, the launch pad, the R&D that went into both. If you factor in donated person hours there, close to $1 million getting to this point. got a more specific number on the cost of Stardust 1.0 here for you. Factoring out more general company expenses, the rocket and the tower together is about $260,000 with labor and materials and other supplies.
Hi everyone. So yes, right now we just got to know the cost of this rocket. I mean, this rocket will just go to a suborbital flight, and that to achieve 1.6
I
kilometers.
got a couple of requests to cancel the background music. That may make the buzz a little more prominent, but if a lot of people feel that way, we can definitely pull down the music.
Okay, so yeah, he said around $260,000 for this thing to be done, for all the material, labor, and everything. I mean, wow, the rockets are really very expensive to make. That is really cool. And thanks, Marina Mann, for becoming a Patreon. Really appreciate that. I just got that. Thank you so much for becoming a Patreon, Marina Mann. And you ask, is there a patent in the works for the new biofuel? Well, they don't have. I don't know whether they are having a patent or not, but actually what they are having is the proprietary. That's what they say, the fuel is proprietary whenever someone asks them, so they don't want to disclose their fuel right
The people
now.
have spoken, the music shall stay.
Yes,
Someone
sir.
asked how many engines Starless Rogue is going to have, the two-stage suborbital. It's a cluster of 4 engines
Yes,
on the first
boosters.
stage,
Okay,
and then a single engine on the second stage.
yeah, I was right then. The image also shows something like that only. Yeah, so yes. How big is it? 20 feet tall, only, and what type of fuel it will be using? So, the engine is a hybrid engine, which means there is, if I'm not wrong, it will be using gaseous oxygen maybe as its fuel, the oxidizer, sorry, and the fuel is the solid fuel. So the engine will be an hybrid engine. So yeah. And right now the views have changed, so there is one lateral view giving the views of the rocket, and on the right hand side we have the top view of the launch tower. So the blue thing which you can see on the right hand side in the
Well, if you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0. This will mark Maine's first ever commercial rocket launch and the first commercial rocket launch of powered by a bio-derived fuel ever. Currently, the rocket is doing all right. All systems go. The weather is a bit of an issue. Due to cloud cover, we're holding from a launch that was originally scheduled pretty early this morning. We're now looking at 2 to 3 p.m. as our window for weather.
Okay, yeah. So I was saying the right hand side you can see the launch tower view. The
Getting a lot
rocket
of
is
comments
at
in chat about the fuel. Feel free to keep discussing it, of course, but I just can't really comment on it. Happy to answer other questions, though.
So as they said right now,
I can
yeah.
talk a little bit about hybrid rockets. Well, it's funny. Someone asked if I used to be a radio DJ. Ryan, the answer is yes. In fact, that's how I met the CEO. I had a radio talk show about space science and exploration in Portland, Maine, and I found out about this rocket company up in Brunswick on Facebook. And so we had a little back and forth, and we got the CEO in to do an interview. We had so much fun that we did 2 interviews. And before I knew it, was interviewing for Blushift. I had to step away from the radio show to focus on Blushift, but it continues. All of the other panelists are still there on WMPG as Scientifically Speaking. All right. We've got a little bit of a treat for you. Blushift founder and CEO Sasha Derry is going to join us in just a couple of minutes for a quick Q&A. Hey, Michelle. Griffin asks, wondering if the fuel being used could be efficient for launches on the moon, Mars, etc. I can say that that is on the drawing board. Right now we're experiencing temperatures comparable to those at the Martian equator, although the pressures, well, there's more here. Alistair Mitchell asks, what materials are you using for structures? Well, the skin of the rocket is a composite, and the internals are a mix of aluminum and steel. Steel mainly for affordability. It's very rare to see that on a rocket, and certainly, our future rockets will have more aluminum, less steel. If you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0, Maine's first commercial launch and the first launch commercially of a rocket powered by bio-derived fuel. We're holding now for weather, expecting clear skies somewhere between 2 and 3 p.m., or at least clear enough to launch. All systems are go on the vehicle. And as we wait, I am joined here by Sasha Derry, founder and CEO of Blushift Aerospace. Sasha, hello. Thank you so much for taking time to join us here.
Good afternoon. Thank you, Seth, and everybody who's out here for suffering through this cold.
Well, someone asked if I had experience as a radio DJ, and I told them how we met.
Yeah.
And this is really bringing back some memories.
Full circle.
Yeah. So how's it been for you today? Before Blushift was incorporated, you were already working towards this day. So we're talking over 6.5 years at this point, right?
Yeah, this is 6.5 years of the accumulation of 6.5 years of hard work of many individuals, and hardly just me, but a lot of really talented individuals to get us here. And it could be a historic moment if we can light this candle. We'll be setting possibly 2 new records, being the first commercial vehicle rocket to launch from Maine, and being the first commercial launch in the world using a bio-derived carbon-neutral fuel. Now, I know a lot of people are going to guess that it's blueberries and manure or ethanol. It's none of the above, but we can assure you it's bio-derived and carbon neutral. But this is incredibly exciting for all of us, and I think there's a lot of anxiety, but we're feeling pretty good right now. Everything technically is in place, and it's just the weather.
Yeah, it really is everything on the line in this moment, and I'm lucky, because none of the buttons that I touch here are going to make anything explode.
Thank goodness.
Yeah.
Unlike what happened last night. No, sir.
No. But it's just been really amazing to see you guys collaborating and problem solving through the static fire tests and through the past couple of days as we get the rocket up on the tower. Seth, you and I have been here since Sunday, setting up the network, getting systems ready, and the rest of the guys came in on Monday and Tuesday. But our engineering team, Luke, Brooke, our interns, Ben, other guys, Mike and Corey and Gerard and others, David Hayricken, have been so instrumental into getting us to this point. And not everybody could join us here. And there's many people who are part of the Blushift team that some live far away, and they've contributed over the years. Whether it was 6 years ago, 3 years ago, or this week, people have been working early mornings, through the days, and late into the night to push this effort forward. For Blushift, in this case also for Maine, but also to demonstrate how
a small launch vehicle, how we can provide ultimately dedicated small launch vehicle access for tiny payloads to space.
Yeah, so let's talk about that a little bit, because a lot of companies right now, they're going for volume, right? I mean, SpaceX is launching like a lot more CubeSats in one go than we ever planned to. We're doing 30 kilograms,
Yep.
and that's it. So we're not competing with them. We're not even competing with Rocket Lab, really. We're carving out this new niche. Yep. Why are we doing that?
Well, I'd like to say, if you bring it down more terrestrially, it's kind of like SpaceX is the freight trains to space, and there's definitely a market for that, a big market for that. There are bus lines to space like Rocket Lab, Virgin Galactic, and Virgin Orbit, and others. And what I expect us to be, is the Uber to space. We're going to be able to, because of our technology, where we're launching from here in Maine, ultimately off the coastline into polar orbit, but how we're going to be operating this company, I believe that we will be able to launch profitably 1, 2, maybe 3 payloads at once in our payload section. For most rockets, they need to collect either very large payloads or dozens of payloads at once to turn a profit. So we think there is a real niche market for us that's currently not tapped by many other companies in the world.
And Blushift is one of the things that makes Blushift so cost competitive is the fuel has a 0 TNT value. There's no cryogenic storage or anything like that, so the handling costs go down as well as the manufacturing costs. And my favorite fact about the fuel is that, well, I don't know if we can call it edible exactly.
No, although I think you could find components of our blend in food products, but yeah, you could eat it. I probably get in trouble for saying this for the bajillionth time, that I could feed to my daughters, and the worst thing that would happen is they might get constipated, but I wouldn't do that to them, I swear. But it's a very safe fuel. In fact, I tossed one of our sample fuels, a small subsection of it, a few days ago with some neighbors onto a fire, and everybody stood far away, and it is no more explosive than a piece of wood. It just burns.
That's amazing.
Yeah. Now another important aspect about why we're able to keep the cost down has to do with the hybrid rocket technology itself. It allows us the throttability and control that a liquid fuel rocket has, but half of the valving and control systems, the tubing and solenoid valves that you might need on a liquid fuel rocket. And that means a lot. That means not only a lot during manufacturing, but of course during the research and development phase, a whole lot less complexity. And because neither our fuel nor our oxidizers are toxic, that means the handling costs are quite a bit less. Launch environmental costs are negligible, except for when we first get our permit costs. And it means that we can feel confident that when we launch off the coast of Maine, that we will not be contaminating fisheries, wildlife, or habitat, or affecting habitat. Something I think that you can't say about many rockets in this world today.
Yeah, so about that, because it's not just a bio-derived fuel, it's also a non-toxic fuel. There's no heavy metals, no rubber, unlike some other companies that are operating vehicles that use a hybrid rocket right now.
Sure. Yeah, exactly, like Virgin Galactic, Virgin Orbit. Yeah, I mean, you can carry our rocket down the road without any special DOT rating with the fuel in it. Maybe not the oxidizer, but certainly with the fuel. And there are zero hazards other than the kinetics of the rocket going down the road for folks. Field questions for 5 or 10 minutes. I know we're preparing to call the FAA again as we narrow down upon the launch window.
Yeah, all right. Let's go to YouTube for comments here. Well, I don't think we have. Oh, here we go. So JJ840 asks, what should I do or learn to get an internship? We take all our interns through the Maine Space Grant Consortium, through their Aerospace Workforce Development Program. So that's who I would reach out to there. And then, Sasha, I don't know if you want to leapfrog off of that, but also they ask, how was the engine designed and what's the nozzle and casing made of?
Sure. So, with a hybrid rocket, the fuel, hybrid rockets can work multiple ways, but we have our fuel inside the casing, lined inside of our combustion chamber. Right now, we use, our engine has not been lightened for normal flight. It's quite literally the one we use as our test engine when we were working to optimize its performance and stability under a NASA grant. However, so the encasing itself is a metal casing, and the nozzle right now is a graphite nozzle that we're using currently. We have plans, certainly the casing will change for Stardust 2.0, and the nozzle, we have some interesting changes for the nozzle as well that I can't get into yet.
Well, maybe we can have a big reveal next launch.
Yeah, hopefully.
All right. So back to one of mine. Another pain point of a lot of folks that are trying to launch a CubeSat is they need to use a crew-rated launch vehicle, and so we're planning to sidestep that by just producing rockets that really couldn't have a person in them anyhow.
Yeah, that's right. We, one thing that we learned when we interviewed about 40 customers and folks within our niche part of the industry, and what we learned from them is that they were really frustrated of launching their CubeSats and experiments to space because they had to make their experiments and CubeSats rated for manned conditions, even though there wasn't an astronaut in the same rocket, because there could be someday. They had to meet the restrictions. That usually adds something like on the order of 30 or 40% more cost to the development time of those CubeSats. Again, since our rocket will be purely dedicated to launching non-manned or personed flight, and be very optimized, very much optimized to 1, 2, or 3 payloads in terms of trajectory and launch timing. We think we can get those costs way down for a lot of our customers. And a lot of our initial customers are going to be in the academic space, from academic and civil researchers. And we don't mean just academic and civil researchers that are in college or postgrad, but all the way down to elementary and high school students. In fact, every state has a space grant consortium that can receive funds to help them develop new science projects or fun science projects that they can launch in space with us maybe, or other companies here in the U.S. And NASA itself has additional funding to also support students and researchers from elementary school right through college years. And so our initial market is to focus on assisting students from any county, any town across Maine, but of course across the country, and ultimately across the globe, to do research in space, suborbitally and then orbitally.
Awesome. And so another interesting way that we're able to keep costs low, of course, is having a small team. I don't know how good this figure is, but I read that in America alone, there's like 120 companies that are preparing to compete for this emerging small launch market. And that most of those companies have significantly more employees than we do.
Sure. So that is, having been a part of the Alt-E team, a renewable energy company,
Oh yeah,
been around since 1999.
let's talk about that for a minute. Let's talk about how you're basically like the Elon Musk of New England.
I think that's an exaggeration, but
Okay, fine, the Tony Stark of New England.
right. I just need more of an attitude and a lot more money. One thing, when I started that up with Nick Albright and Jason Federspiel back in '99, we did that with blood and sweat equity, started from the ground up, and it was a lot of hard work, just like Blushift, but we did it organically, and we grew it with its own funds and its own revenues to where it is today. And, it's really successful today, once again, because we have a compact team, but also because we have really capable individuals on there. And that, in many ways, is very similar to Blushift. We have a core group of very capable people, and we are growing this organically, and we're planning to keep the team tight, because when you look at the marketplace for launching suborbital payloads to space or orbitally, you can see that the potential market, in some cases, there's less value in 1 year than the cost of running a company with 100 or 200 people. So we're trying to keep our expenses low and our headcount not crazily high, besides the fact that we can't afford it, but so that we can have a sustainable business into the future. Not one that's here for today or tomorrow, but one that keeps on running and running off of its own revenue profitably. And that's not easy to do in the space industry. You need a lot of money up front to do things like this launch here. And then the next launch, we will need quite a bit more. We will be going to the outside world to seek investment, develop our fully commercialized launch vehicle, suborbital launch vehicle called Stardust Rogue.
And correct me if I'm wrong, but it is our stated goal in the next 5 years to create 40 aerospace jobs here in Maine.
That's correct. That's right. Yep. And I hope that whether or not we're successful here today, or if we end up launching and having to scrap a launch for another date, I hope that we serve as an example of what Mainers can do, and whether it's another company who starts up as a rocket company, or kids who are students today and want to start up a new satellite company, or want to develop a new software company for downloading data, to analyze data from space. I hope that we serve as inspiration to kids here in Maine, but anywhere that might be a rural state, and they might not think, well, we're not Florida, we're not Texas, we're not California, but we can do it too. And to have that go-gettedness and that sense of independence that you can kind of get from more rural states such as ours. And so I hope, if nothing else, we serve as an inspiration to other folks, and especially kids.
Yeah.
I think that I need to, my alert system is pinging me, and it's telling me that I need to get back with the team here, so I'm going to have to hand over the microphone back to you, Seth.
Awesome.
But I'm happy to answer the questions post-launch, or if we scrub it, answer any final questions that people might have later on.
All right. Thanks, Sasha.
Thank you, Seth.
A busy guy, especially today. Always nice to chat. Well, if you have questions for Sasha specifically, maybe if you can note that in chat, and I'll try and take them down as they roll on by. Got a couple already here.
Okay, so we just heard the conversation between the CEO of the Blushift Aerospace and the commentator, and yeah, that was pretty epic. I mean, the directly hearing from their company CEO is really very good. So, and we got to know about some really good insights about this rocket and their company itself. And yeah, more I get to know about this company, more I'm falling in love with this company.
Mokwan asks, are we actively hiring? Not right now. You can send a resume to marketing@blueshiftaerospace.com. We'll keep it around.
And yes, as you can see, there are some wheels with this launch tower. So this is a mobile launch tower, which means they can literally take it anywhere with the rocket
Mike
attached.
Clifford asks about barge launching and the benefits of it. Well, barge launching is tricky, right? Because that's a whole new system that can have malfunctions when you're trying to get something as complex as launching a rocket done.
I wish I could have seen the face when it was active.
The advantages are mobility, being able to move that barge wherever you need to go to launch, so long as it's on the water. Can open up new launch windows that you might not have if you're just stuck on the ground. It helps with exclusion zones. Of course, a certain amount of area around the rocket, no one can be there for safety. And even in Maine, which is known for having a pretty low population density, it is really hard to find a place to launch a rocket. And so when we scale up and start launching to orbit, it may be simplest just because of the exclusion zone, just to get away from anybody for safety, to just head out to sea. There are some companies that launch from barges today. I think the main one is Copenhagen suborbitals. So we know that as long as you sufficiently stabilize that barge, which does become a challenge as the rocket gets bigger, but it is feasible. And then at some point, the rocket may be feasible to just launch from the water, like the old Sea Dragon concepts.
Yes, the sea launching is currently in operation from the China's. China is launching from the sea.
One more thing about barge launching. Many launch sites, especially for orbital launch, are coastal. And the nice thing about a barge is as the sea level rises, the barge, of course, rises with it. So it may become not just convenient, but a necessity.
Guys, if you have any questions, you can just put down in the chats and I'll try to answer them. Whatever I have the knowledge of. And yeah, one interesting fact about this rocket is that you can see in the left hand side of the screen that one of the fin is colored in blue, right? And all the other fins are white in color, but only that fin is blue in color. And the reason behind that is
Arjun UI asked if we need to have a self-destruct system on the rocket. For a rocket, this small flight termination is basically just cut the oxidizer flow. But as we scale up, that's something that we also have a couple plans on the drawing board.
okay. And yeah, I was talking about the fin. So the reason behind that colored fin is the better
Donna Reggio asks about recovery plans.
visual ability.
In all seriousness, those recovery plans may involve snowmobiles.
So if because this rocket is white in color, so it can get camouflaged in snow.
Stardust has a nominal flight and landing. It'll be within a couple hundred feet of the launch tower in this nice wide open space. And we could carry it back, but boy, a snowmobile would be more convenient.
Exactly. So yeah, so that's the reason why that fin is blue in color, to get a better visual aid when they have to recover it or in the flight. So the nose cone is not visible obviously from the beneath when the vehicle is in flight, but the bottom section of the rocket is visible. So if you can get a dark color in the sky, then that means that could be a rocket. I don't know, but yeah, the color of the fin is because of the better visual aid. It actually proves to be a better visual aid. That's the reason.
Kathleen Holly makes a good point about CO2 coming from the fuel. There's a combustion reaction going on there as the fuel and the oxidizer mix. So carbon dioxide is produced and released as the rocket, fires its engine. Now, one of the things that makes our fuel unique is that as you produce more of it, it absorbs much of that carbon dioxide back into it.
I mean, I'd be the same way. I'd be like, but they would just.
So it's a carbon neutral rocket fuel, which can greatly offset the this rapidly growing industry of small satellite launch. Offset its
That's
carbon
interesting.
footprint. Sorry.
That's interesting. I mean, if it produces and it also sucks it bad, maybe that is used in the reaction only. The CO2 which is produced is used up in the reaction only. That's what carbon neutral means. Maybe. Is it? I don't know, but I think so. That's what they meant to say. No, Jack Drummer. They are with the or this is just a sounding rocket, which you are right now seeing. With the main rocket, which is an orbital class rocket, is their red dwarf rocket, which they are aiming for a launch in 2024. No deployment of the satellites. Sean Stone, there is where's the rocket going? It's just going into the sky 1.5 kilometer above the sea level and then landing back with the parachutes on. That's what it is. Hi, you Carlos, and it is yes. Thanks for that. ZYWL. So I can't pronounce your name right now, but yeah. You on? Sounding rocket is nothing but a rocket which is capable of suborbital flight and carries some experiments or instruments on board to perform the research type of things in microgravity or something like that. So that's what this rocket will be doing. It is going to a suborbital flight and has three payloads on it, three customer payload, three payloads, yeah. One was from research, means a student set is there. One is only testing a new type of alloy in space, so microgravity, some kind of things are there. Okay, Thomas,
Yeah.
stop spamming, Thomas. Stop spamming, Thomas, or otherwise mods will put you on a timeout.
Now, if you're just joining us, welcome. It's a Blushift Aerospace live stream of the launch of Stardust 1.0. This is our prototype sounding rocket demonstrating our bio-derived fuel in flight
But it is cool because you
out
get to
of
see this.
Loring Commerce Center, the former Limestone Air Force Base.
And then
Sorry, Loring Air Force Base in Limestone,
my
Maine.
memory, I remember like 5 minutes later hearing a little bit or something. I don't know if that's true. Yeah.
Andy asked what kind of biofuel is used in this rocket. We don't know yet, but there's a solid fuel as an
Indications are weather may improve at 2 to 3 p.m. Eastern. So we will evaluate at that point whether or not we can safely conduct a launch.
That would be really fun to watch.
All systems are go on the vehicle.
I would have loved to have watched this at a land.
Okay, so
And then land.
Filling the oxidizer tank now and
Yeah.
holding for weather.
okay, so the there is being fueling which is done, so the
I love, I mean,
Chicken
oxygen tank
Makeover
is being fueled.
suggests we should make some merchandise. We actually do have some merchandise through Spreadshirt. If you go to our website and click on the merch button, you'll get redirected. There's shirts and coffee mugs and a couple of phone cases, things like that.
And Seshagiri Rao says, just one comment, I like this channel and has been following it for every launch. This is really very good. Thanks you so much for that appreciation. Really appreciate that. And the kind of biofuel they use, nobody knows actually. We only knows that it can be derived from the farms which Maine has, and that's all. Nothing more about it. And I think I need to change the countdown timer. They won't be launching, maybe, let's see. Right now the fueling is being done, so the oxidizer tank is being fueled, and so the oxidizer tank is also not like cryogenic, used in cryogenic temperatures. So yeah, that's what. If the other fuel is a solid one, so that must be already fueled. That must already be there, and only the oxidizer needs to be fueled up. That's what they are doing right now. If you have any other questions, you can just ask me and I'll try to answer if I can. And if you want to support the channel, do consider becoming a Patreon. Link is down in the description, or super chat is enabled for one-time funding. It really helps this channel to stay alive. Yes, that one guy. Actually, the thing is, with the space companies, the height and the weight is there. The height is 20 feet for this rocket, but the thing with other parameters is like they don't want other companies to then take some hint out of it and develop their own. Okay, so that's why they kind of keep it secret until and unless they're fully sure that nobody else will be able to make it. So maybe that's the reason. And obviously these are some these are the rocket companies having a rocket technologies. So and the rocket technologies are often considered to be in to be under government restrictions, means nobody else who does not live in that country can work in a rocket company. Do you know that? If you don't know, yeah, the countries, almost all the countries in the world have this rule. If you are working in a specific rocket company, that means you need to be a resident of that company, because the rocket technology is used in missiles, and that is used in military. So you don't want a rival country to know that technology. Maybe that's the reason. Yeah. Nope, and the company hasn't provided any information about that, so that's why. I'll update the timeline whenever we get any update from that. So yeah, let's see how this rocket flies. And if you have don't know the flight plan of this rocket, this rocket will go on to an apogee of 1.56 kilometers around, and at around t+11 seconds the engines will be cut off, and then it will coast till apogee for 10 seconds, and then it will come down at apogee. There will be separation of the booster with the payload bay.
As we wait here, might as well introduce you to the members of the team.
Okay, listen into them then. and then obviously after the separation, the drogue chutes and the main chutes will be deployed for both the booster as well as the payload. So both will be recovered after they touch down. That's how the rough flight plan will look like.
So earlier, you get to hear words from Sasha Derry, founder and CEO. He founded a solar retailer, Alta East Store, in 1999. It's now a $24 million a year organization and acquired Real Goods. I think the first commercial retailer of solar panels in the US. Acquired them in 2019. Founded Blushift in 2014. Brooke Halverson, our lead test engineer, is responsible for working on performance testing logistics, manufacturing, and hybrid rocket motor assembly and testing. Luke Sandin, our senior mechanical engineer, assists with performance testing, oxidizer system design and evaluation, MATLAB code development and staging simulations. David Hayrikian, mechanical engineer. David Hayrikian, mechanical engineer, experienced in 5-axis CNC milling and founder of Maccabee Tech. He's responsible for CAD/CAM development of the hybrid rocket motor components, developing production processes. Our executive assistant is Bonnie Etheridge. Kind of keeps us all in line.
Actually, hi Dimitri, and Andy says liquid biofuel such as
Matt Parker,
biodiesel.
technical advisor.
Okay, listen into them first.
So led a test engineering team at SpaceX where he helped develop, qualify, and produce the Merlin engines for the Falcon 9 launch vehicle. Oversaw development and operations of the Rutherford engine for Rocket Lab's Electron small-sat launcher. And now manages the engineering team at Fiber Materials Incorporated to develop advanced composite materials for missile defense and space systems. And I am Seth Lockman, Communications Director, in charge of public, media, and government relations. I also handle Blushift Web.
Well, that was a bit weird cut. Hope they didn't lose the sound there. Let's see. Okay, so Andy says the liquid biofuel such as biodiesel or bio-SPK, synthetic paraffin kerosene, may offer potential possibilities similar or even superior to traditional RP1. Yes, those are the biofuels or the synthetic biofuels as they say, but those are you can say not non-toxic in nature or eco-friendly in nature. The fuel which is being used in this rocket is a bio-derived fuel, which means and the company sign in their communicator of the companies also says that the thing which they have used for this, for the making of the fuel for this rocket, can be found in Maine farms. So hopefully that involves some plants only, maybe, and yeah, that's how they have made this fuel. Maybe we don't know, but yeah, because this he's clearly mentioned that thing that they can be found in the farms. So yeah. Hi, good morning from Canada. Hope the weather gets better. Yes, that one guy. Let's see, and what do we have in store for us? Oh, from the enthusiasm and everything, I believe they do have some good footage of multiple camera angles, as you just saw also that this is the camera and they have other two cameras also, and they have the onboard camera as well as the payload camera. So I'm excited for this launch. Let's see what we get out of it. Hi laptop Mark from Mexico. Okay.
More Blushift people you should know are interns funded by the Maine Space Grant Consortium's Maine Aerospace Workforce Development Program. James Giltner assisted with the layup of carbon fiber fuselage and main rocket casing, wired recovery, tether and quick disconnect arms, helped with on-site testing and rocket stacking. Ben Lemieux is a mechanical engineering major, wants to focus on rocket engines and aerospace engineering. And he was instrumental in rewiring our upgraded test stand when, under the NASA grant, we moved from an engine with a 4-inch diameter to a 6-inch. Kaylee Gallant helped model oxidizer behavior in the tank during flight. Contractors to thank: Gerard Desjardins, working on programming for the flight computer. Steve Savoy, composites expert, owns Savoy Composite Solutions, focuses on tooling design, process management, equipment evaluation and upgrades, workflow analysis and quality compliance. And at Blushift, Mr. Savoy manages design and manufacture of all composite components in the Stardust launch vehicle. Michael Ostermecki is a mechanical engineer and parachute rigger extraordinaire. If you're just joining us, this is Blushift Aerospace, a live stream of the Stardust 1.0 launch. This will be Maine's first commercial launch and the first commercial launch of a rocket powered by bio-derived fuel. Right now, all systems are go on the rocket. We're holding for weather, hoping skies will clear as forecasted between 2 and 3 p.m., all the way up to our flight ceiling of 5,200 feet. The clouds do appear to be receding a little bit. But of course, the final decision will be made based on weather reports.
So Andy, the apogee for this flight will be around 5,200 feet, which means 1.6 kilometers.
Eric Emery asks, are there plans for launches in Brunswick in the future? And the short answer is no, but we would never launch anything out of Brunswick. It's too densely populated. There's buildings, people, roads, that it just wouldn't do. Now you could control a mission from Brunswick, kind of like how Just a second.
Yes, Blues Traveler, that's a nice fact which you did. The V2 rocket used alcohol, which was used derived from the fuels. Potatoes were fermented and distilled. Yes, that was one thing which they did in with the V2 rocket. The Germans did with V2 rocket, but this one, this is the commercial first ever commercial rocket. I don't think so that was a commercial rocket. V2 rocket wasn't a commercial one, but this is a commercial rocket. So that commercial phrase, whenever they say their first bio-derived rocket, they always add commercial to it, because this is, yes, the first was the V2, and then if you take another one, then this could be
All right.
second, but the commercial is the first.
I get my weather reports from rocket engineers. And what Mission Control is advising at this time is that the weather conditions are worsening.
Worsening.
Cloud cover does not look like it's going to recede for 2 to 3. We can shoot for 3 to 4 just as a formality, because you always just keep trying. But barring a real surprise here, just leveling with everybody, it looks like the chances of a launch are not great right now. But that just means that we'll get to do this again next week.
That's not a very good sign out there, but let's hope we get to go, have some. Let's hope the weather improves. That's what we can say right now. And thanks, Peter, for subscribing. Really appreciate that.
So, I believe I was answering the question, will we ever launch from Brunswick? And to make a long story short, no. For a rocket launch out of Brunswick, it just wouldn't work. You can't do that out of well, for Maine, it's a city. Now, with that said, it is possible that similar to what Virgin Orbit plans to do, or what Pegasus was, that launch system. Certain rockets can kind of be, slung under a 737, flown up to, above the densest part of the atmosphere, and then launched. And something like that could be done. Brunswick has, perfectly good runway at the executive airport. But for us, for rockets, vertical launch, if you will, Brunswick is not an option. It could be a good option for mission control, for data storage and processing, and business incubation, which is ongoing, actually. We are one of 2 rocket companies in the state, headquartered at Tech Place at Brunswick Landing. Now, where would Blushift launch? Well, for suborbital, we'd love to see the spaceport develop the former Loring Air Force Base, and maybe get up here a little more often. For orbital launch to polar or sun-synchronous orbit, which isn't something, it's not the only thing we can do, but it's the market that we want to go after. To do that safely, we really need a coastal launch site, or if necessary, you know, we could look at a barge launch or something like that. So that would be either in or based out of coastal down east Maine, somewhere in Washington County, probably. Elizabeth Kettner asks, what is a commercial launch? That is just a launch with paying customers, and Blushift Aerospace is well, it's not a government entity, right? It's a company, or a private entity. And so when we launch something, it would be a commercial launch. Mike Pafford asks, what are the 3 logos on the rockets? Glad you asked. So in our current view, the top decal is the Blushift Aerospace logo. Let me see if I can make it a little bigger on the screen here. So that's what you're seeing, just much farther away. The middle one, that decal is something we're all very proud of. It says Made in Maine. And then below the interstage at the top of the engine section of the rocket, that's the logo of Rocket Insights. They're one of our payload customers for this mission. Now in the chat, someone advised that I might be pronouncing this wrong, so apologies if that is the case. But Rocket Insights wanted to sponsor our launch. One of their partners had a personal connection with the state and thought it was really great what we were doing. And so they're sponsoring the launch, and they're flying a CubeSat with us. Their enclosure will contain a traditional Dutch wafer cookie called, and this is where I hope I'm pronouncing it properly, stroopwafels. Kind of an homage to their Amsterdam-based parent company. So those are the 3 decals from that angle.
Yep, Dimitri, if it would have
And
been
from
launched
this
from
angle,
equator, then the weather
you
obviously
can
would be
see
different.
down at the bottom, another Made in Maine decal. On the interstage, just a Stardust 1.0.
Okay. On the equator, if you ask me, on the
Elizabeth
equator,
McGovern
but
asks, how heavy is the rocket? Unfueled, I believe it's about 540 pounds, and then fueled, it's close to 600. A couple questions about the timing of the launch. We're targeting 2 to 3 p.m. However, the outlook is poor. Weather forecast does not suggest that we'll have clear skies at that time. We're going to continue holding just because we can, and we can always hope that the weather will cooperate and improve.
Exactly. So the Maine is very far away from the equator, but if you ask me if this was from the launch was from the equator, obviously the weather would have been different. Although also the launch site where this is situated, that is the Maine, they can't have equatorial launches from there because it's far away from the equator. That's why. But they can the advantage of this launch site is the polar orbit mainly. They can have a really good polar orbit with the very efficient uh, orbital injection. So yes, that's what they aim for basically, a polar orbit with the CubeSats on it. What is the purpose of this launch? The Kellyworks ask. The purpose of this launch is to test, or you can say, demonstrate the technology that the not the liquid fuel, but the bio-derived fuel which it is using can be used as a rocket fuel. Although there are some other payloads on it, as the Blues Traveler has already saying that a CubeSat prototype of new
First trip.
Kellogg's Research Labs of
My
Nashua is
God.
there.
It's been a minute. How are you doing? Asks if I can speak to career opportunities in the future at Blushift. So it is our stated goal to create 40 aerospace jobs here in Maine in the next 5 years. And we also support the initiative to create a spaceport here in Maine, which over its lifetime is estimated to create something like 75,000 jobs. We're not hiring right now, but depending on the results of this flight, we might be hiring very soon. You can reach out to express interest. Probably the simplest way to do that is just through the contact page on our website. But if you send a resume to the marketing at blushiftaerospace.com, I'll see it. David Stevens says, hopefully still edible after recovery, presumably in reference to the Stroop waffles. I like telling the engineers, don't toast the Stroop waffles.
Is there an earthquake in Central America? I don't know yet, but yes, there is. So, whosoever is watching from there, be safe. Hope you are safe there. And it's a pretty dangerous earthquake. Seems like around 6 on Richter scale. Be safe, guys. I should say that only. Pan Galactic Tech asks what is the oxidizer they are using. Hopefully not peroxide, but hopefully, I don't know, maybe it could be peroxide, but some unofficial sources said that it was gaseous oxygen, simply gaseous oxygen, but don't know, I don't know. Could be peroxide, because liquid oxygen, obviously they are not using liquid oxygen, could be peroxide, don't know. An official source once said that gaseous oxygen is being used, otherwise we don't know yet.
Space Gnome asks how much thrust the engine can generate. So the engine can burn at 2 Gs, which then, fighting the Earth's gravity, means it can accelerate straight up at 1 G.
Okay, that's a good insight of the thrust of the rocket. So it's as they say that it is producing 1 G of thrust initially, and then the thrust is 2 G. Let's see how this rocket moves up then. Then if that's the case, I don't expect it to just blast off to the to air. Maybe could be slow. It could be slow down there, but I don't know. Let's see how does it go. Yes, Pan Galactic Tech, actually they are using a hybrid engine only for this rocket, right? The fuel, there is a gaseous oxygen, maybe that's the case, and the other thing is the biofuel, that is the solid one. So the engine is hybrid, that's why, could be that's why they are using gaseous oxygen down there. Any plan? Kai Nestle says any plans going orbital? Yes, they do have a plan with the with their red dwarf rocket. They are currently aiming at 2024 for an orbital launch with the red dwarf rocket.
Oh, here's a good one. Reese Collins asks, what's the difference between polar orbit and the low Earth orbit? So the term low Earth orbit really speaks to how high the orbit is going to be. The term isn't formally defined, I don't think. But basically, from the moment that you can get to a stable orbit, which is a little bit above the Kármán line, out to a couple hundred miles is usually what we mean when we say low Earth orbit. Now, a polar orbit, that refers to the inclination of the orbit. So rather than its altitude, we're saying if you imagined a flat disk extending out from the Earth's equator, would your orbit be perfectly on that kind of a plane, what we call the ecliptic, or would it intersect with that plane? And assuming it's a
Yes, he's explaining it in a very nice way.
well, assuming that there is an inclination, then you can ask, what is that angle? And if the angle is 90 or negative 90, then you're going to pass over that planet's poles. So you can be in a polar orbit and a low Earth orbit. You can be in a polar orbit and a high Earth orbit. You cannot be in a polar orbit and a geosynchronous orbit.
Exactly, because geosynchronous orbit means you have to be pointing to perfect a certain area on the Earth at every time in its orbit. That's what a geosynchronous orbit. And in a polar orbit, the Earth always rotates
Quite
beneath.
welcome, Reese.
That's why.
Kindness asks if we plan on going orbital, and the answer is yes. We plan to develop our presence in the suborbital market first, and then work on a 3-stage to orbit launch vehicle, which we're calling Red Dwarf. The plan is to focus on launching from a high latitude to a polar orbit, but it could reach other orbits as well. The beauty of our 30-kilogram payload capacity is that the CubeSat is the primary customer. There's no ride sharing. And so if they need to go to a weird orbit, all they need to do is find 2 or 3 other people that also want to go to that same orbit, and we can just do a custom mission. And even on the drawing board is launching a single CubeSat. Ooh, Riley Dunn mentions you could be in a polar geosynchronous orbit, but not polar and geostationary. Well, rest assured that I will be Googling that this evening and educating myself. I'll be using Google Scholar, don't worry. Mike Underwood asks, do cold temperatures affect launches? Good question. The biggest effect that the temperature has is on valves. Condensation around valves can turn into ice, and so we want to make sure that doesn't happen. Easiest way to control that is just heating. Rocket Guy asks, would you be using Alaska launch site for an orbital launch? That must be a reference to Kodiak. It's certainly an option. Yeah. If we can launch from Maine, though, we might not need to launch from an island.
Okay, they took
Getting
our
a
question.
rocket and all of its payloads to an island, it can be a little difficult. But what's really difficult is realizing that you forgot that one part back on the mainland.
Okay, that was a good thing. So he answered my question. And yeah, okay, so that's a good info we got there. I was like, there's a rocket company known as.
Thank you for the clarification, Christian. Bradley Hubbs writes, geosynchronous just means the orbital period is 24 hours. Geostationary is geosynchronous that hovers over the same point on the surface.
Oh, that I
All
had
right, well, I
also.
just learned something rather publicly.
Same here, same here. Okay.
Thanks, guys. Drew Goff asks, will you guys be developing reusable rockets? That is on the drawing board. Aiden Eisenberg asks if we're ever going to design or operate a orbital launch vehicle that carries more than 30 kilograms. Currently, we don't plan for that, but the engine is going to be fully modular. So in time, Starless Rogue and Red Dwarf will be more like standard templates, more like guidelines than models. And so if the MAREVLs can be configured in such a way that we could launch a larger payload and the mission called for it, I don't see why not. But we're dealing with hypotheticals that are years away. The reason for going with that 30 kilogram payload is, well, we touched on it earlier about CubeSats being the primary payload. And based on our research, that's where the demand is. MC Official Plays Space asks, will the rocket be landing intact? That is the plan.
Yes, Andy, you are right. Biofuel is more cleaner and more powerful on the diesel engine, but this is a rocket engine, and the fuel which they are using is kind of a new one, and let's see what we get in here. When this rocket will be in flight, we only have seen this. We already have seen actually a static fire of this engine. That's it. And during the static fire, when the engine just starts up, there is a fire near the engine, and then I mean that could be because it is just the turbo pumps must be like pumping it and coming to its full power. That's why a little fire and then the thrust develops. So yeah.
CB Manley asks how we keep the rocket stable for the first few seconds before thrust takes over. And that's a really good question. We've got that launch rail. The guide tower is about 72 feet long. A little longer than average. In part because Stardust 1.0 has a little bit of an irregular construction with steel in there. It adds weight to the overall structure, and so it just takes a little longer to get up to headway speed. Airbus 390 asks how many stages is Stardust 1.0? It's a single-stage rocket. However, on descent, it will split into the engine and payload sections, which will then remain tethered together as the rocket descends on parachute. So there is a separation, but there's only one stage. Well, Kendra Green asks, my science class is watching the live feed and would like to know what the rocket is fueled by. That's just terrific. High class. Study hard. So I can't say too much about what's in the fuel. It's our secret sauce. It's proprietary. I can say that it's a hybrid rocket engine, meaning that we have a liquid oxidizer and a solid fuel. Most rockets are either totally liquid, so they have a liquid oxidizer, liquid fuel, or solid fuel, where you have the oxidizer and the fuel suspended in a kind of a gel-like substance.
Okay, there we have, they aren't using the gaseous oxygen, and now actually they're using a liquid
So we have a little
oxygen.
bit of each.
Liquid
With the solid
oxidizer.
fuel, you can get some really terrific energy density, a lot of delta V, a lot of bang for your buck. And with liquid oxidizer, you have start-stop ability, throttle ability, and with only half of the systems being liquid, you save a lot on parts and plumbing, and there's fewer components that can malfunction, and you save weight and cost and all kinds of things. And then with the solid fuel, it's incredibly stable. It's got a 0 TNT value. So if hybrid rockets are so great, why don't we see them everywhere, right? And the answer there is because you're passing the oxidizer through or around the fuel core in the reaction chamber. As the fuel is consumed, as the rocket operates, the combustion chamber changes shape, right? And this is happening while the temperature and pressure are changing around the rocket. So it can be pretty difficult to sustain a stable reaction, especially at larger scales. And so that's one of the big technological hurdles that we had to overcome, in addition to inventing a new rocket fuel.
Exactly, as in if you will look out the cutout section of a hybrid engine, it works like a solid rocket motor only, but the thing is, in the core, as he mentioned, core combustion chamber, the liquid oxygen or the liquid oxidizer flows, and since the fuel is being consumed up, the area which it has to flow, it increases when the fuel gets consumed up. I won't be able to actually make you understand without the figure, but I got the point what he was saying. So yeah, it's a difficult task, but they did it. That's why the hybrid engines are a thing to be made only if it is necessary. Like Virgin Galactic made because they had to have this stoppability and throttle ability of the rocket engine, because they need to have astronauts on the board, or the people on the ship, spaceship Unity 1, if I'm not wrong, that's what it is called. So yeah, when you have humans, so you really need to have a engine on and off switch whenever if something goes wrong. So yes, that's the reason. um uh, the guys who are just joining in, let me just tell you that here you are right now seeing the launch tower view, as well as the view from the camera on the screen. And yes, we are right now on a hold on the launch because of the weather, and the weather does not seem to improve also for this launch window. They actually can extend the launch window to 3 to 4 Eastern, but we need to be waiting as in what happens next, because right now the weather seems to get worsened with the time getting past. So yeah. Andy Joe says, have they done the static fire test before? Yes, they did it. And uh, Abdullah has this okay, so yeah, yes, they did the static fire test. You can just find out, or I can have that here. And they did around 2 static fires if I'm not wrong. And yes, the engine fired up. Goose Flava says, is this a manned launch? No, not at all. This just have some experiments on board to experience, which will experience some 11 seconds of near microgravity, and yeah, those experiments will run. Oh, the stream is actually getting a bit longer than expected. Wow. Actually, I wouldn't have done this if the support from you guys wouldn't have been there. I was not in my that mood of streaming today at all. But then, what is to be done, it is to be done. So yes, I'm here with you. Abdullah, it's not orbital rockets, just a sounding rocket here, and yes, it will just go up and then straight down. Okay, so hi F1AZ Gaming. Thanks for that $4 super chat. Really helps it the channel to stay alive. Thank you so much for that. Oh, really appreciate that. Sometimes it feels like uh, the hard work which I am doing is getting some recognition. Thank you so much for that. Really helps this channel. With your super chats and your support on the Patreon uh, is the main thing for my channel. I should say that is what this channel why this channel stays alive. Okay, so right now we feel like the weather won't improve. That's what they said, but it's already around like 4 hours since we are streaming, and now just waiting and waiting and waiting to see this rocket fly. Actually, there is no problem with the rocket is fully operational and ready to just lift off. Only thing is with the weather, and it is being like in the, I should say, that's what the timer is being like improve is changing and changing according to whatever information I am receiving. And yeah, that's what else could we talk about? Maybe we can talk about the Starship, the static fire which they did in quick succession right now, not right now, actually yesterday or day before yesterday. They did 3 static fires of the SN9 prototype in quick succession. That is their pretty much a good record which they set. And after that, Elon tweeted that they need to replace 2 of the engine, which needs actually some slight repairs. That means there will be some time now since the SN9 flies, and because the last time that happened, it took around 26 days for the replacement to become and assembled, and then they need to do another static fire for checking out everything is going perfectly fine. So there could be a literally a month long wait since we can see the SN9 actually fly. So yeah. Tomorrow we have a launch of the rocket lab, and around 12 hours from now, and I really actually want to I have to make the Kerbal simulation for that also. I don't know how will I do it, but I'll try to do whatever I can with the, and that the rocket labs that with that launch, the rocket lab will be
If you're
starting
just
their
joining
launch
us,
campaign for
this is
2021.
Blushift Aerospace. We're doing a live stream of our launch of Stardust 1.0. This will be the first commercial launch in Maine, the first launch ever of a commercial rocket powered by a bio-derived fuel. Quick update on the weather. We were targeting 2 to 3. Now we're looking at 3 to 4.
Oh man.
Odds of the weather improving at this point are pretty low. I did see a question in the chat from NASA asking when will we reschedule to if we have to scrub. The answer would be after the long weekend, after Martin Luther King Day. So potentially Tuesday or Wednesday.
Okay, so if they have a scrub today, that means another art for the launch. 3 to 4 means yes, I need to again update the countdown time, the timer, and yes, we do have to wait again. And
To launch, we need low winds, which we have actually. There's abnormally little wind for Limestone in the middle of the day, in the middle of the winter.
okay.
Clouds are the main issue. The rocket's going to reach 5,200 feet above sea level, and we need less than 50% cloud coverage up to that height. At this point, cloud coverage pretty greatly exceeds 50% at and around apogee. Cloud ceiling appears to have lifted somewhat just based off of my own observation here. But it's not, well, cloud cover is not less than 50% all the way to 5,200 feet. If we do have to scrub today and are unable to launch due to weather or another issue, then yes, as soon as we determine a new launch date, we will make sure to let everybody know. It'll be all over our social. We'll schedule another live stream. We'll update the website, Eventbrite, Google Events, however you found out about us. We'll make sure to keep you posted that way.
Okay, so yes, thanks Blue Traveler for mentioning that. Yes, there will be another static fire, and we actually need Elon actually tweeted that it will take some time now, because previously they had to replace the engine. It took 26 days for that to happen, and the everyday astronaut also tweeted in a reply that
Well,
I
thanks
should
everybody
be
for your understanding and support.
that I should be heading home now then, and they don't tweeted yes, it would be probably wise. So that means there will be some time now, at least a month, since we get to see SN9 fly. So let's hope that happens as fast as possible.
It's definitely a little bit strange to work so hard on literal rocket science and then be looking at a scrub for clouds.
Okay, so yes, actually, he's very right. Like, we work so hard for the rocket science. They work so hard for the rocket science, to designing, implementing, 6 years in total. And then when it's the launch time, the weather interferes, and I can feel that. I can actually feel that. But don't worry. Whenever I would like to say them, don't worry. We are with them, and I would like to see whenever it launches. So no worries with that. We're just waiting for the weather to clear.
All right, it looks like Sasha is about to do an interview with the press, so I'm going to duck the mic for a couple minutes while he does that.
Okay, so there is some interview going on with them. Maybe we can get some insights on what could be the possible next steps then, after the press conference is over, and I'll keep you posted whenever I get any updates, so don't worry about that. So yes, they are in work since 2014 in this, and this thing which you are right now saying is the culmination of all the hard work, research, investment, and everything for 6 years. All of that is being culminated with on this launch. So man, whoa, that is pretty large amount of hard work. So this weekend is a launch weekend for everyone because we have this just a sec. Okay, yeah. So we have the on the Saturday, means tomorrow, we have a Rocket Lab launch of their Electron rocket name. Another one, Leaves the Crust. That's the mission name of that. And on the 17th January, we have Virgin Orbit Launcher One attempting a launch demo 2 mission, and that is a pretty unique in its own because the rocket will be launched with the on the airplane, and it will be separated at a certain height, and then the rocket motors will fire up and deliver the payload towards the orbit. So yeah, it's a pretty unique thing to have. And then on 18th January, on Monday, we have a Starlink mission from SpaceX. Wow. And on 19th January, we have China's aerospace launch of their Tiantong 1 mission. And then on 21, again we have a SpaceX Transporter 1 mission. I mean, wow. I have a pretty busy week ahead, that's for sure. Need to be like literally killing my sleep and providing you the content. That's what it is. Uh, Stacy said, when will they launch this one if not today? Okay, see, if they don't launch today, then they have this planned for the next week, maybe on Tuesday and Wednesday. That's what they say. So yeah. I don't know how will I be able to make these many simulations. Let's see how will I do. And he says China is busy with the moon samples. Yes, they did a pretty good job with collecting the moon samples. I mean, what China is right now doing with the space program is very incredible. Literally very incredible. They are going in with the full ambition of whatever they can, and literally heading towards a space superpower, I should say that, and literally will be competing with NASA in just a near future. I can literally see that because they have this. They literally just went to the moon and collected the moon rocks and brought them safely. Then there is the Mars mission which is going on, and that is also a very ambitious mission because in just one go in their first attempt only. Although this is the second attempt, but during the first attempt they missed the Mars. They weren't able to inject it into the orbit, but in this mission, in the second mission, they are just not going with the orbiter. Okay, they had a failed first mission, but right now they, for the second mission, they are going in with the full flow. They have a orbiter, they have a lander, and they have a rover, all in one mission. I mean, nobody has ever done that, and China is doing that. And then they have this reusable launch vehicles also planned. They on December 2020, they actually did some testing with their reusable launch vehicle, that is Long March 8 rocket, and yes, they launched it and the launch was successful. Although they didn't recover it, the recovery will be recovering it and reusing it will take time, but they tested the throttle control of the rocket and the decoupling, yeah, the stage separation of the rocket, and it went perfectly fine. And for another year, means for this year, they have like 40 plus launches already planned. Okay. I mean, and that is only from the space agencies of the China. I mean, the Chinese government space agencies. Yes, 40 plus launches from that only. There are some private partners also there, private companies also there, which will be launching hopefully in 2021. The actual see, the problem is with the weather, is not with the winds, as they said. The problem is with the um and the clouds, and we can see the clouds is very heavy there. Although they have pushed the launch window around 3 to 4 now, and that's why the countdown has changed. So let's see what we get then. Yes, Andy Joe, the moon sample from the Mons Rumker, where the Chang'e 5 landed and collected the samples, is very different, because that is a pretty younger site from where the NASA have the moon rocks. Like the Apollo missions collected the moon rocks from where the soil was around 3 to 4 billion years old, and the China collected the samples from around 1.6 billion years old. So we could be knowing some thing which we didn't know from the samples, and China has promised that it once they have done their research, they will share the samples with the world, as NASA also gave some sample to China when the Apollo mission was completed, around 1 gram of the sample. So maybe NASA could also receive some of them. Let's see what we get, and the comparison between those two samples will be actually be of very much science um, significant, because we can actually compare the formation of the moon 3 billion, how the moon was 3 billion years ago, and how it is like 1.6 billion years ago. So yeah, we could get some information regarding that. This December 2020 month was very epic for space and science fans. Okay, because actually they we had so many missions that went on, and we got this in December 2020 we got two samples from the extraterrestrial land, the Chang'e 5 moon samples, as well as the asteroid Ryugu samples from the Hayabusa 2 mission of Japan, yeah, of Japan. And we also witnessed the SN8 flight of the SpaceX. Also the China's reusable launch vehicle, a Long March 8, also launched. I mean, yeah, the December month was pretty epic for mm, space fans. Um, uh, so Andy says, yes, there are so many space missions in 2021. Yes, there are indeed. James Webb Telescope is one of them, and uh, that could be the you can say that could be one launch which I'm most forward and most importantly looking for in 2021, because James Webb Telescope is the engineering masterpiece which will be deployed in space. And the deployment of the James Webb Telescope will take around a week in space, actually a week. That's how complicated James Webb Telescope is, and it's around took around $1 to $2 billion for just its construction, and we have been waiting for so much time for its construction to complete and finally the launch. And 2021 is the year, hopefully, that we get to see its launch. And people say that ISS is the engineering masterpiece right now with the most complication and the biggest machine which any human has ever built. Yes, it is indeed, but the second one, if you ask me, that would be the James Webb Telescope. So yes. So guys, if you have any questions, you can certainly ask me in the chat, and I'll try to answer them if you have. And if you want to support me in what I do, you can always support me on the Patreon. Link is down in the description, and a super chat is enabled for one-time funding. Dunk 406 says, thank you for your knowledge and time explaining and answering the questions. Thank you so much for your appreciation. Yeah, that's what I want to say. It's for you, and it's my passion also to spread awareness and to actually make people aware of
If you're
what
just
is
joining
going
us,
on
this
in
is a
the
Blushift
space
Aerospace
industry.
live stream of the
Well, thank you guys.
launch attempt, our first launch attempt for Stardust 1.0.
It's scrub for the day. What is it? Looking like it is. Just a sec.
If it's ours, no.
So I've got kind of a tough announcement here.
We have one like it that we had the sanitizer.
We are ceasing launch attempts for today. The launch is scrubbed due to weather. The cloud ceiling just will not cooperate. So huge thanks to everybody who joined and stayed on the live stream, even when we weren't so sure about the launch window. And There's been amazing comments and questions in the chat, and it's been really great to see all of you. And thanks to all the engineers and the volunteers who worked so hard to secure the field and coordinate traffic, and everyone who put, you know, years and years of blood, sweat, and tears into this launch attempt. We'll try again, probably on Wednesday. We'll have a meeting, finalize that, and I'll, you know, make sure everyone gets updated wherever you are, however you find out about Blushift. It's definitely not the best feeling, but you know, the rocket's fine. We'll just try again on Wednesday.
That's how simply you say your feelings when you really wanted to launch this thing into air, but wasn't able to because of the weather. That rocket is fine, we'll try again on Wednesday. So yes, a lot of time put into this, have to have the right launch time, and the weather can't rush it. Yes, exactly. It is 100% and understandable, Adam, as you say. Yes, it is, because we don't want, at least we don't want rut to happen, and that's what we are here for. So it is now official that it's a scrub for the day. I've been streaming for around 4 hours now, and
well, thanks everybody for your supportive parting words.
Yes, no worries. You can try again on Wednesday, and I'll be more than happy with more preparations and all. So yes, we can actually see this thing fly again on Wednesday. That's not again, but yeah, that's the thing. So I think I can end this stream now, and yes, maybe we can join in for this again tomorrow. So we do have a launch tomorrow of the Rocket Lab, so do join in for that. I'll be streaming that, so don't miss that. That will be pretty epic to see the Rocket Lab also beginning its launch campaign of 2021 with the another one leaves the crust. Angel Saints, I appreciate your effort. Thank you so much for that, and yeah, thanks Octagrabber for constant support and constant motivation. Really appreciate that. I think I can now put the stream to end, or if you have any questions you can ask me, and then I can end this stream. But I don't think so there'll be any questions now. We already have such a long discussion on this company and the rocket with, yeah. So thank you so much for everyone. Thank you so much everyone for joining in, and do join in for tomorrow also. Around 12 hours from now there is a rocket launch. Do join in for that. I'll be there with you, taking your questions and our answers, and we'll see another one leaves the crust. So until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.